Very brief.
Okay.
So, as part of it,
Very good morning.
yearly wise, they
Yes.
A very good morning to all the respected dignitaries and the enthusiastic participants who have joined us today for the commencement of the second online familiarization workshop of Indian Nanoelectronics Users Program Idea to Innovation based on nanosensors and optoelectronics devices. I am Nilanjana Medhi.
And I am Rajan Singh. We are your host for the inaugural session, and we wholeheartedly welcome you all to the second online workshop. For everyone's information, the session will be recorded for our internal record. All the participants are advised to check their INUP WhatsApp group for any status updates and requested to keep themselves muted at all times. If there are any queries, feel free to drop them in the team's chat box.
For the inaugural session, I would like to invite the PRBR IIT Guwahati, Professor Parameshwar Krishnan Iyer, to deliver the welcome address. Professor Parameshwar K. Iyer received his PhD degree in chemistry from the Central Salt and Marine Chemicals Research Institute, Bhavnagar, India, in 1999. He was a postdoctoral researcher with Technion, Haifa, Israel, from 1999 to 2001. University of California, Santa Barbara, USA, from 2001 to 2003, and Case Western Reserve University, Cleveland, USA, from 2003 to 2004. In 2004, he joined the Department of Chemistry, IIT Guwahati, as an assistant professor and was promoted to a full-time professor in 2013. His current research interests include design and development of advanced functional organic small molecules, polymers, hybrid materials for optoelectronic devices, sensors, imaging, and therapeutics. With this brief introduction, now I request sir to please start the session. Over to you, sir.
Thank you, Nilanjana, for this nice introduction. Very good morning to all the participants and my colleagues present online here. I also express my sincere greetings for the Saraswati Puja. It's a very auspicious day celebrated in this part of the country. And I think we are beginning this event, this workshop on a really very auspicious day, and hopefully we all will have blessings of Goddess Saraswati on all of us during the workshop time and throughout the year. As my colleagues mentioned, we at Center for Nanotechnology, IIT Guwahati, have been very fortunate to have got this project from IIT, and we are looking forward to extend these facilities and expertise available at IIT Guwahati to all interested colleagues, scientists, research scholars, and other UG students that have been told the numbers are quite high. So overall, this workshop has more than 500 participants present or attending this workshop. Among them, more than 140 are faculty members at various levels. We also have 170 students or researchers or at the senior level. We have UG and PG students. That number is also more than 140. And we are very fortunate to also have industry participants. We also have a very renowned scientist, our Honorable Director, Professor Rajiv Ahuja himself is a very renowned scientist working in areas related to this topic. He will be speaking very soon on the various aspects of the institute and definitely on the sensors and optoelectronics. In addition to that, my colleagues, Professor Dipankar and Professor Akshay, will also be highlighting to you all the importance of this workshop as well as the facilities that are present at Center for Nanotechnology, which you all participants can definitely benefit by the interaction and attending today's workshop as well as future program that we have. So I think it's a great opportunity, not just for my colleagues and students of this institute, but across the country, you all will have a great opportunity to form this bond with the institute, the center, and hopefully we can carry forward this relation so that you are benefited to develop whatever the kinds of devices, optoelectronic devices, sensor devices, and any other kinds of small portable handheld devices that is probably possible to fabricate here or you can learn here. So I think the opportunities are really huge. IIT Guwahati really offers a great avenue for you all to come forward, learn, and interact with the experts, not just from the institute but also from the industry. And hopefully you all will have a great time in the next 3 days that this workshop will continue. With these few words, I take this opportunity once again to welcome you all to this workshop and hope we'll have a great interactive session over the next 3 days. Thank you so much.
Sir, for the wonderful welcome speech.
Now, moving forward, we would like to invite our chief guest of the day, Respected Director, Sir, IIT Guwahati, Professor Rajiv Ahuja, to deliver inaugural address. Professor Rajiv Ahuja has joined IIT Guwahati as an officiating director from November 7, 2023. He is the director of IIT Rupert from 2021. He is also a professor of computational material science at Uppsala University, Sweden. He is one of the most highly cited researchers and top 5 material scientists in Sweden and India. He has done his PhD from IIT UK in the year 1992. Same year, he joined Uppsala University in Sweden as a postdoctoral fellow. He became assistant professor in 1996, assistant professor in 2002, and became a professor in 2007 at Uppsala University. His main area of interest is computational material science, with focus on energy, hydrogen storage and production, sensors, as well as high pressure physics. Sir has supervised 30 PhD students and more than 35 postdoctoral students. He has published more than 1150 scientific papers with H index of 100 and number of citations more than 47,000 in peer-reviewed journals. He has been recently elected the Fellow of Royal Society of Chemistry, London, APS Fellow by American Physical Society, USA, and appointed in the advisory board of the Journal of Materials Chemistry A and Material Analysis from Royal Society of Chemistry. He has been awarded many prestigious awards from KV and KVS Sweden and elected member of Swedish Royal Society of Science and KVS. He has been awarded the Best Alumnus Award from IIT Guwahati for excellence in research for the year 2021. Over to you, sir.
Thank you. You can hear me, right?
Yes, sir, you can hear you.
Okay. And so first of all, I congratulate all of you and for this workshop, which is given online. And also thanks to all of you to inviting me and say a few words. And nowadays you don't need to justify that how important is this area. And we have seen that in many platforms, not only in India, but also in outside India, that how important are the sensors and the optoelectronic devices. And when we talk about sensors, I can say that the sensor is the biggest market, world market right now, actually. So when we talk about semiconductor industry, the sensor is one of the biggest area where we can use our expertise and we can be a leader on this area. And we have here at Department of Nanotechnology, and they are working in this area for a long time now. And of course, we need the facility for this kind of a program. And we like to thank MITI, not only supporting for this program, also the facility what we got in MITI, and which was inaugurated even last week. So we can use those kind of state-of-the-art faculties, state-of-the-art facilities, and to make those kind of nano devices in lab itself at IIT Guwahati also. So it is a very niche area, and it is aligned with the government effort when we talk about the semiconductor mission. Of course, we want to make chips in the end, but sensors are equally important, and it has been used in everyday life, and it's everywhere. Sensors are everywhere. And there are a lot of those sensors which we are importing only, but we are not making them in India. So now we have an opportunity that we don't need to import the sensors from outside, and we can make it to be in India with the Make in India concept. I think MITI has another program, actually. I'm chairing that, chairman of that center. Is a center for sensors. They set up in CGCRI in Calcutta. So I'm chairman of that session, and I can see that the way they are working for the sensors. Only thing about there, I have given the advice that we should not import any sensor from outside. We should make our indigenous sensor. And that's important to be able self-reliant when we come to the sensors. And with this kind of workshop, I think you have many invited talks, not only within India, but from outside India also. And as you mentioned in the beginning, that there will be almost 500 participants in this conference. And at least you are training those 500 people, right, in this area. So that's a good initiative. And then, because when even we talk about semiconductor mission, we talk about skilled manpower. We need skilled people, and we can skill them in making those small devices like nano sensors in itself in the lab. They can be really readily employable in any semiconductor industries. And I know IIT Guwahati is one of the leading institution in this area when it comes to nano sensors. And there's a department of nanotechnology which is doing very excellent. So I'm sure that this workshop will lead more, I can say that more skilled people, and many faculty members are joining, many research students will be joining this workshop. So they can use this opportunity to interact with other experts also, although it's online. But nowadays, this is the best option. One can join online. And I was talking to Akshay, and he told me that in the beginning, first two we will have online, and then the last one we will have in the physical mode. Is right, Akshay?
Yes, sir. So
Yes.
we have an offline familiarization also that is followed by hands-on.
Yes.
Short-term projects and so on.
Okay. So it's a good opportunity. Yeah.
Ultimately, a few startups will graduate.
Okay. So you are also encouraging the startup also in this one, right?
Yes, sir.
Okay. So it's a good opportunity, and if you are these 500 participants who are joining, and if some of them they want to have a startup in this area, and they can incubate at IIT Guwahati, and IIT Guwahati will help them. Then we have also our incubation center, and they can come and they can incubate their company and start up here, or they can do in their own institution where IIT Guwahati can play a key role to help all of them. So, in the nutshell, I would like to say that this is a very key, important area, and this kind of workshop will help us to make self-reliant, at least in the area of nanosensors or optoelectronic devices. And this is aligned with the government semiconductor mission, where we need more skilled manpower. And in coming this 2-3 days when this workshop will going on, our all participants will enjoy this workshop in the online mode. They will listen to the expert India and abroad, and I hope this interaction will be very fruitful for them, and it will be create a new possibility and opportunity for them also. With that, I will stop here, and I wish all the best to all participants and a successful workshop this coming 2-3 days. Thank you very much.
Yes.
Moving on. Now, I would like to invite Professor Dipankar Bandyopadhyay, who will introduce you to INUP IDF Innovation Workshop, as well as briefly explain the selection procedure for the same.
So thank you, sir. Thank you, Professor Ahuja, for your encouraging and stimulating inaugural address as a chief guest. Thanks, Professor Iyer, for your welcome address. My job here is to run through a few slides to all the participants to explain what this particular program that is called INUP, that is Indian Nanoelectronics Users Program, I2i, is all about. Okay, so I'm just going to share a few slides. to make sure that you are able to clearly understand what is the agenda associated with this particular meeting. There is a slide. So I hope my slides are visible. Can somebody confirm that my slide is visible? Yeah.
Yes.
Thank you so much. A very good morning to all of you. On behalf of IIT Guwahati, we welcome you all for this for the inaugural session of this online familiarization workshop that is called Nano Sensors and Optoelectronic Devices. And we will have a 3-day-long program starting from today until 16th. I am going to run through the different lectures and the workshops that has been arranged for you. But before that, I would like to give you a very brief overview of what INUP is all about. So you know that this is a flagship program by NEI IIT, that is Ministry of Electronics and Information Technology. The purpose of this workshop is to bring in the workforce together, bring in the workforce related to the semiconductor devices, especially at the nanoscale, and develop the human resources, upskill the human resources in the nano semiconductors or nano electronic semiconductor devices. Okay, so as you see from the left hand side, the workshops that are arranged here that are associated with the fundamentals and familiarization workshops, which you are participating right now, and then it will be followed by a offline workshop where you will be coming to IIT Guwahati, for a
Sir, there is no audio. Sir, there is no audio.
Dear all, there's a technical issue, so kindly wait.
ऐसे भी ना ಈಗ ಪಾಪ ಇಷ್ಟೇ ಅಷ್ಟೇನಾ ಇವತ್ತು ಏನೋ 7 ರೂಪಾಯಿ ಜಾಸ್ತಿ ಐತಲ್ಲ ಬರೀ 200 ರೂಪಾಯಿ ಹೇಳ್ತೀವಿ ನಾವು 10 ಸಾವಿರ ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀವಿ ನಾವ್ ಯಾರಿಗೆ ಹೇಳ್ಬೋದು ನಾವು 10 ಸಾವಿರ ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀವಿ ನಾವ್ ಯಾರಿಗೆ ಹೇಳ್ಬೋದು ಇವತ್ತು ಏನಲ್ಲ ಈ ಮತ್ತೆ ಅಷ್ಟೊಂದಿದೆ
Yes, thank you so much.
अच्छे बच्चे सब अच्छे बच्चे
I hope my slides are also visible, right? Is it visible now? Yes. Now,
Yes, sir.
thank you so much. So sorry for the interruption. There was a network issue in the middle. So as I was discussing that this particular training program is a year-long training program, and this year-long training program has been laid down into different types of workshops, which is starting with this familiarization workshop, where you will be given a brief introduction about the fundamentals. Now we have conducted one online workshop in December. And this is in February. We are conducting the second. So at the end of this particular familiarization workshop, there will be a quiz that will be conducted, and based on the two quizzes, the results of the two quizzes that was announced in December and which will be announced on 16th. The results of those quizzes, we are going to shortlist a group of candidates from all of you who are going to come for the first offline familiarization workshop, where you will get a set of, again, you will encounter a set of lectures. Before, you will be shortlisted for the hands-on training, where you will come to IIT Guwahati for 2 weeks, and you are going to develop some of the basic fundamental devices, like say MEMS devices, like say suppose SAW devices, like say suppose OLEDs, okay, like say suppose solar panels. Those trainings will be given to you, in order to ensure that you are having some hands-on training on the basic semiconductor devices. And while you are doing this online and offline workshops, your job will be to develop a project proposal, okay, which is at this level. So when you are supposed to develop a kind of project proposal, while you are into the online familiarization, offline familiarization, and hands-on training programs, you are going to develop the project proposals, which are going to implement for 3 months in the beginning, which we call as a short-term project. And then, if you are doing well, then you are supposed to extend these short-term projects for the medium-term projects. So essentially, in a year-long time, you are expected to, starting from the online familiarization programs until the completion of these projects, leading to some publications and patents. Okay, so this is the overall idea of the INUP i2i. So if I summarize what I have said, you are right now at the base of the pyramid, where you are attending the online familiarization workshops, where fundamental and translational aspects of different semiconductor devices with the theme of nanosensors and optoelectronic devices have been done this time. And then, say suppose in the first program, we have about 300 participants. Here also we are expecting about 400 to 500 participants. So out of them, we are going to call a group of participants who are going to do well, who will do well in the quizzes, or who has already done well in the quizzes, for this offline workshop. And in this offline workshop, when you come here, you are again going to listen to different experts on different topics. And while you are doing so, you are going to have a local mentor who is going to help you in developing a proposal. So at the end of offline workshop, we will request you to prepare a poster presentations. Okay, and that poster presentation will be in the line of the project that you will be attending at the end of this cycle, right? So you will start building up your proposal at the level of the offline workshops. Now, after you finish the offline workshops, a group of people, not all who are participating in the offline workshops, but a group of people who are doing well, who has really, qualified all the basic, necessary things that we are expecting from you during the online and offline workshops. You will be called for the hands-on trainings, and during this hands-on training, you will be given practical exposure of how a clean room looks like, what are the different protocols of clean room, how a semiconductor material is clean, how a semiconductor device is made, say suppose how a silicon is doped, and then from there, how do you develop transistors, how do you develop different types of electrode arrangements, microfabrication, all these trainings, you will stay here for 2 weeks, and you will be given a kind of hands-on training where you will end up doing, each one of you end up doing five devices as tutorials. Once that happens, we also have a provision for NSQF certification. This time, hopefully, we will be able to produce. This is not sure. We are working on it, but hopefully, after you finish the hands-on training, apart from the certificates that were given last 2 years, we will be able to provide you with an NSQF certification subject to qualification of an exam. So you have to appear for an exam, qualify the exam. Training, you may receive NSQF certification. We are working hard on it. The entire curriculum from the online familiarization to hands-on training, until hands-on training has been arranged in such a manner so that you have the basic qualification for the NSQF certification, but then you have to qualify for an exam. Now, until this offline workshop and hands-on training, you will be developing your project proposal. Those who are interested, under the mentorship of some of the faculty at IIT Guwahati, and you are going to submit the proposal to a committee. I'm going to discuss about the process of project proposal approval a little later. But then once you submit the project and once it is approved, you will be able to execute your project at IIT Guwahati for 3 months initially, which is typically. So online familiarization is finishing in February. Offline will be in March, April. Hands-on will be in May, June. Okay, and typically project he will be executing from July to September, October. And if you are doing well in the projects, your project will be extended for the medium-term projects, and then you can execute until next February. And your objective will be to publish some papers, publish patents. And then one thing you may note that in these publications, what you are achieving here, none of the faculty members of IIT Guwahati will be the author. This will be your own publication. Okay. So this is, I will take up questions at the end of the presentation. So let me first go through all the full presentation first, and then I will open the discussion for your question and answer to address all the questions. So we are essentially at the level of third year. If you have understood the lecture until this point, so we are essentially in the third year. We are organizing two virtual familiarization workshops, and then from there we are going to bring in for the offline 2 online and 1 offline familiarization workshop, and then from there we are going to invite you for a hands-on training. Okay, then from there we are going to ask you to submit some projects. Okay, before you are going to publish and patent and prototype. Okay, so this is the typical timeline we are working with. So level 1, it is in December, which has already happened. February, right now it is happening. April, May, we are going to have the first offline familiarization workshop. Then we will have a hands-on training in May, June, as I have mentioned previously. And then you are going to execute the short-term projects for 3 months, medium-term projects for another 3 months. Okay. And then, we are expecting in between, you are going to achieve some of the publications and patents, which will be our own. As all of you know by now that we are operating through this particular web page, all of you are visited and logged in because you are participating after registering through this portal. All the information related to whatever is happening will be available in your login. And you can, this portal has been created by IIT Guwahati in such a manner so that through this particular portal, you know that INUP i2i is happening in 6 different institutions. At the bottom of this particular slide, you can see that IIT Bangalore, IIT Bombay, IIT Delhi, IIT Guwahati, IIT Kharagpur, and IIT Madras. There are 6 partners. Through this particular login, you can log into any one of these institutes to register your candidature and participate in the online and offline workshops and execute your short and medium-term projects. Talking about the program that we have from today, tomorrow, and day after. Right now, we are at the inaugural session, and we are very thankful to our honorable director to address us as the chief guest and inspire us in this event. And then we also very fortunate to have Professor Iyer in BRBR, who has welcomed all of you. Following me, there will be a brief welcome address by the head Center for Nanotechnology.
after the technical session starts, like Professor Roy Piley will be talking about devices for detection of breath. Okay, Salil will be talking about how to write, journal paper, publication, high impact review. So these are the things you will see that slowly, you will be given the nitty-gritty details of technical writing and how to develop proposal, how to write papers, how to write patents. So some of those ones that will be discussed in these three aspects. And then you will see Ravindra will talk about development of sensors, design and development of sensors, and Ankush will be talking about, photo. See, remember that photo detector. Remember that these are all experts. They are working in these areas for long, minimum 15 to 20 years, right? And then they will be sharing their thought processes, which I wish that all of you participate very keenly. The program has been recorded. Those who cannot participate continuously, they can also listen to the recording. It is important from the perspective because on 16th, the last event, you will see the quiz. Because we have requested all the speakers to give us at least 10 questions. And after these lectures, these 10 questions will be, summarized into a group of questions at the end of this event, which is the last event, which will be the quiz, where you have to appear for the quiz, and in the quiz there is a marks number 1 which qualifies you for the next level of offline workshop, and number 2 is that marks also has a relevance in the NSPF certifications. So my request to all of you will be to listen to the lectures very, very carefully, very, very sincerely, note down all the points, before you appear for the quiz. Now, day 2 have a very good combination of software packages, industrial participants, and at the same time other experts like solar photovoltaic. You will listen from Amit Singh, Raj Kodhi is from Adani Power, then from perovskite solar cells, IIT Bombay, Professor Pradeep Nair, hybrid perovskites, Professor Manojit Bag. Okay, and then you will have a tutorial on SCAPs, then loss, and then you will have a bird's eye view on solar photovoltaics from Dr. Gayatri Nathu. Okay, she's from Applied Materials. So you can see a combination of softwares, a few lectures on the modern materials related to sensors and photovoltaics and optoelectronic devices. And then some software training is also given. Now for the software training, you have to contact our project engineers will contact you. Our team will contact you for the downloading of the software, for the installation of software at your end, and there will be a kind of a mock session perhaps today. I think that has been arranged, so that tomorrow you don't waste much time and you are comfortable with the software and the tutorial that has been taught online. You are able to follow them very, very meticulously. The last day, you can also see again a set of talks are there on the nano sensors and optoelectronic devices in the first session. Then you have one very interesting session on building a venture, challenges, roadblocks. So here you will be looking at, if you develop a technology, how exactly you translate the technology from Dr. Swapnil Sinha, and then you will have some very basics of density functional theory, and you are going to use a software called VAS, okay, where you have to do a kind of some tutorials of the density functional theory. So overall, you can see the program is a combination of a lot of fundamental things, a lot of applications, a few software where you can explore the fundamentals as well as the applications. There are industrial experts, and also there are experts from the translational point of view. So it's overall a kind of 360-degree package. Before 16th, you will face the quiz, and in the quiz you will be given only from these lectures whatever question has been given by the experts. From there you have to answer and you have to qualify for the offline workshop as well as for the NSTF. So overall, if you qualify for this from this online, you are going to come for an offline workshop. As I was mentioning, in the offline workshop, you are going to be taught the clean room protocols, the lithography processes, deposition systems, the characterization systems like morphological characterization like electron microscopy, confocal microscopy, optical microscopy, then materials characterization like Raman, UV visible spectrophotometry, IR, different computational tool, productization, patent writing, product design. So my request to you will be, please diligently follow these lectures and qualify. We will all be very happy if you are qualifying for the offline workshop, but we will also ensure that those who are not serious, they are not coming for the offline workshop, because you have to understand that your travel, your subsistence at IIT Guwahati has been sponsored by BT. So if you are not participating very sincerely in all the lectures, and if you are not qualifying the quizzes, okay, then it will be difficult for us to accommodate you in the offline workshop. So I request all of you to participate very keenly in all these online lectures, and then appear for the quiz in a very diligent manner, so that you can come here where you will not only get an exposure of the fabrication, characterization, testing, and other computational tools, but also we will give you a very detailed idea about how to write a patent, how to write a publication, how to write a proposal, and how to translate an idea into product. Okay. So when you come to IIT Guwahati for offline workshop, in that not only you will be given all these ideas, all this exposure, but also you will be having one-to-one interaction with your mentor group and faculty members. We are going to arrange panel discussions so that you develop an idea, and around that idea you develop a proposal. And we are going to have a poster presentation from you, where during this April-May, you are going to create one project proposal at your end, which you are planning to execute. Now, that can be anything. However, as you are coming to hands-on later, as you are finishing your hands-on, this will be a little shorter duration, 3 to 5 days, whereas as you are coming from hands-on, which will be for 2 weeks, there we are going to polish up your proposal to the level of, number one, it is feasible, and number two, it is executable at IIT Guwahati. And we are going to have, you will have mentor groups from the PhD students, from the staff members, from the faculty members, which will ensure that that your project proposal is going to the level which is executable. Number one, which is executable. Number two is that it is executable at IIT Guwahati. It is novel, and then it is publishable and is patentable. So you have to develop a kind of top quality idea. We are looking for top quality ideas here. And then these top quality ideas, how do we really deliver the project proposal? And from that project proposal, how do we implement it at the facilities? You must appreciate that any institute, any center cannot have all the facilities. So we have to really do a little bit of fine tuning, as per the facilities that are available, and then transfer this top quality idea into a scientific publication, and then from there a kind of a device or a prototype. So that's the overall objective of your proposal. Okay, and in the hands-on training later on, when you are coming for 2 weeks, you are going to participate. You are going to have exposure on photolithography. Now this is more serious because you are entering into the clean room. In the previous stage, in the offline workshop, you will be just shown things, right? But then as you qualify for hands-on training, you will be given practical exposure of lithography, materials characterization, thin film characterization, device fabrication process. And then these 5 devices, all of the people who are coming for hands-on training, these 6 devices you will fabricate on your own. Starting from a silicon wafer, you will go for a MOS, MEMS, SAW, perovskites, LEDs, and biosensors for microfluids. So you are going to develop a host of devices. This will come as a kind of package. So in hands-on training, there is very less lecture, but it is all you are going into the laboratory, and then you are testing yourself with some of the very standard semiconductor devices to get an idea about how to take a silicon wafer, how to cut it, how to clean it, how to put a photoresist, how to develop a pattern on top of that, how to develop a source and a drain and a gate, how to do a kind of deposition of metals, how to do deposition of oxides. And then from there, how do you do a kind of, once you develop a FET or a SAW, how do you test it, the electrical characterization? How do you do the morphological characterization in electron microscope? And then, how do you check the device performance? So this entire cycle of event for at least 5 devices you will perform at IIT Guwahati. So that's why my request is, for to you to, attend these sessions very, very diligently. Again, the same from me. Yeah, slide. But please,
It was his origin.
Yes,
It's fine.
you get it. Teacher leader. No issues. Great. So once during the hands-on training, during the offline workshop and hands-on training, you are going to develop a project. And this project you will be submitting by the time you are finishing the hands-on training for the short-term qualification of the short-term project. Once you submit this project, this will be reviewed by the expert committees at IIT Guwahati. And if your project is approved, you are going to give, when you are coming for offline workshop, your travel and accommodation will be covered with certain limit. When you are coming from hands-on, your travel and accommodation will be covered with certain limit. And when you are coming for project, also your accommodation and travel will be covered at IIT Guwahati. And with certain restrictions and limits, right? So once you are submitting the proposal, it is going to be reviewed by a committee, and you will be given a kind of time window in which you have to come to IIT Guwahati and execute this. The idea will be executing this. You are going to publish some documents, some journal papers, and file some patents. And you have to do a proposal defense at the end, so that you can really show that what exactly you have done here, what is your output, and if you are doing well, then your project will be extended for another 3 months to go for a medium-term project. Okay. So overall, this much. So I welcome you all. I request you all to participate very, very diligently. All the events associated with this INUP program that is laid down over for next 3 days. And I wish you all the best, and you make sure that this opportunity, whatever opportunity you are getting, you are doing it very, very diligently. And you are making use of this opportunity as much as possible. Okay. So I stop here, because it will be good that if we have some interaction session with all of you. So the session is open for a few questions. There are 2 procedures. You may raise your hand, and at the same time, what you can do, you can drop your message at the chat box. Both ways are possible. If you raise your hand, I can just request you to turn on your microphone and ask the question, or otherwise you can drop the question in the chat box. Okay, so thank you so much for your time. If you have any question, please raise your hand or put your message in the chat.
Somebody raise their hand.
Yeah, Tejaswi. Please unmute yourself and ask the question. Tejaswi, any question? Anybody has any question? Yeah, Alok.
Hello.
Alok, please go ahead. Unmute yourself and go ahead. Yeah.
Sir, am I audible?
Yes, you are.
Yeah. Sir, thank you so much for a nice introduction about INUP. Sir, I developed one model based on the light dependent register circuit. Sir, I have installed in 2 of the place in my village. Now, sir, I want to carry my model at industry level. So now, what kind of help we can get from the INUP Sir, and one problem is that in this project, only one sensor LDR is imported, and rest of the things are totally Indian.
Yes.
So, sir, how INUP can help me to make this sensor so as our innovation totally means totally dedicated to our country, means we're totally independent of the importing the things like sensors.
Yes, Alok, thank you so much. We are actually looking forward to support people like you. So number one is that you should participate and you should submit a short-term project here to make sure that the sensors part you are executing at IIT Guwahati. So you should first go through all the online workshops, offline workshops, hands-on training, so that you can come in June, July and develop a sensor here. That is one side. The other side is that as far as your device is concerned, what you do, you write to us on a separate forum. Okay, we are supporting startups. We are supporting different types of institutes in terms of collaborations. So you write separately to us. We are going to request to you to submit a proposal based on what exactly you want to do at IIT Guwahati. We are going to review it and we are going to get back to you as quickly as possible to see the feasibility of your project that can be executed at IIT. Okay, am I clear?
Yeah, sir. Okay, sir. Thank you so much.
Thank you, Alok.
Thank you, sir.
Kushbu, can you please unmute yourself and speak?
So am I audible? Hello.
Yes, you are.
Very
Yes,
good
you are.
morning, sir.
Morning.
Sir, actually, right now I'm doing my PhD in solar cells, and I have also
Yes.
attended an offline workshop at Banasthali Vidyapeeth.
Yes.
But what the kind of difficulty what I faced that they offered that device fabrication techniques, but they didn't allow us the materials they had. So in case if we get selected for the offline one, do we have to carry our own materials or we'll get it from the lab itself?
We did not carry anything. All materials will be supplied by INUP i2i.
Okay, sir. That's what I was supposed to ask. Thank you, sir.
You have to just come here and execute your right. Everything has been sponsored by me.
Okay. Thank you, sir.
Thank you. Ravi Shankar?
Hello, sir. Good morning.
Yeah, good morning. Please tell me.
I'm from Kolhapur, and I have work done from the gas sensor materials in PhD work done. So I can ask my proposal sent for the patent in the gas sensing material for the coating material with the help of INUP.
Yes, but before that, first you have to execute you have to go through the whole process. Online, offline, hands-on, then submit project, then patent. Okay. So you have to go through the full process because we want to make sure that you are executing a scientifically accurate and a technologically also accurate device. So you are supposed to create a whole system. We are going to see here. None of the faculty members are taking any credit out of the whole process, right? So none of us will be co-authors. None of us will be co-patenters. Our job objective here is to oversee, supervise, and really look at the things that you are doing and make it more technically and scientifically accurate. Okay.
Yeah.
So go through the whole process.
Actually, I have completed a project on the IIT Bombay.
So you completed one project already under INUP?
Work complete किया है project through.
तो कंप्लीट कर दिया है आपने IIT बॉम्बे में?
लेकिन पेटेंट पे अभी काम करना है सर वो.
पेटेंट आप तो पहले एग्जीक्यूट कर लीजिए, फिर IIT बॉम्बे में पेटेंट एग्जीक्यूट कर लीजिए.
Okay.
Okay. Why do you want to change the institute?
Okay, sir.
Because facilities will be very similar. Okay.
Okay, sir.
Okay. Yeah.
Thank you, sir. Thank you. Thank you.
Shivam? Shivam?
Yes, sir. Good morning.
Good morning. Please go ahead.
Yes, sir. Sir, I am from IIT Surat, second year student. And sir, did I am eligible for offline workshop in summers, May and June, if I qualify the quiz? Second
year BTech student.
No, sir. Integrated
BTech
masters in physics.
You will be eligible. You will be eligible.
Yes, sir. Thank you, sir.
Yes. Srinivas? Srinivas, please unmute yourself. And Srinivas, please go ahead. Please unmute yourself and go
Hello,
ahead.
sir.
Yeah, please.
Good morning, sir.
Good morning.
Sir, actually, my name is Srinivas, so I'm pursuing PhD from IIT Silchar.
Yeah.
So, is there any chance for me to attend the offline fabrication of? So, actually, I'm working on perovskite solar cells. So, there is any possibility for us to attend in the IIT Guwahati to do my research work?
100%. So first you do the online workshop, qualify the quiz, come for the offline workshop, qualify for the hands-on, and then come and execute your project.
Okay, sir. Sir, we need to have to pay anything regarding our things to if we qualify all the things.
No, your travel and your accommodation, travel up to I think 4,000 rupees to and fro, that will be sponsored. And I am not sure about the number that our team may confirm. There is an upper limit to travel, but that is covered. Your accommodation will be arranged at the hostels at IIT Guwahati, and your food is covered, and all materials required for your research is covered.
Sir, one more doubt, sir. One more. Hello.
Yeah. Yeah, go ahead.
Sir, actually, my friend is working in as an faculty in Andhra Pradesh. So, is there any if they are attending for these workshops, there is an possibility them to qualify after qualifying. There is an chance to allow them to offline workshop. Actually, previously say he's trying, but he's not getting for the
request them to
workshop.
register immediately, and then join the online workshop. Okay, have they registered in this one? No.
Yes, sir. He registered actually right now.
So it is possible. Same is the model for which I have discussed with you.
Thank you, sir. Thank you.
Yeah. Thank you, Kavita.
Yes, sir. Good morning. Good morning. Sir, am I audible?
Yes.
Sir, I'm a diploma faculty. Basic background is instrumentation. Will it be difficult? I don't have any sensor fabrication basic idea, sir. As I have seen, all the people have done many projects on this. Can I able to do the project or something after attending this workshop? I haven't attended workshop in previous December 2023 you have conducted. This is the first workshop I'm going to attend.
Yeah, so this is the December workshop. You need not December the workshop in December and February are very similar workshops. Okay, so any one of the two, if you attend, it is fine. You need not attend both of them. You have to attend one of them and you have to qualify for the quiz in order to qualify for the offline workshop. If you are able to qualify
workshop only, sir.
All the lectures you participate, you listen to the lectures, and then on 16th, you will be having a quiz. You qualify for the quiz. You can come for the offline workshop. And then from there, again, there will be a presentation. From there, we are going to choose the hands-on people. So this actually is for those people who are having less exposure, but then to give them the adequate exposure so that they can execute some projects. Can I answer your question?
Yes, sir. Thank you, sir.
Thank you. Priya, please go ahead. Yeah, everybody mute. And please, if you do not have any question, please take down your hands. Okay? Yeah, Priya, please go ahead.
Good morning.
Good morning.
Sir, actually, I am the PhD student from KR Mangalam University. Am I audible, sir?
Yes, yes. Please go
Yes,
ahead.
sir. Actually, I just want to work on the biosensor metal-based, metal-based biosensor. I want to work on that. Can I get the seed grant for this if I am working on this?
Yes, yes, you can fabricate biosensors. You can fabricate biosensors at the IIT Guwahati labs. Okay, we are going to support you with the fabrication facilities, with the characterization facilities, with the testing facilities, as well as we are going to support you with the consumables that you need. Is that fine with you?
Is there any procedure regarding this?
You have to appear for this online workshop. You have to get the quiz through. Then you have to come for the offline workshop. You have to submit a proposal. You have to come for the hands-on training. You have to brush up the proposal to the level of execution. Okay, and then if you qualify, your project qualifies to the committee, then you will be execute the project at IIT Guwahati. Is that clear?
Okay, thank you, sir. Thank you.
Thank you so much, Lokesh.
Hello.
Yeah, please unmute yourself. Lokesh, please unmute yourself.
Hello.
Yeah, please go ahead. Yogesh, please unmute yourself. Yogesh, please unmute yourself. Ajay, can you please go ahead?
Yeah, good morning, sir. This is Ajay Kumar from Telangana State. So currently I'm working on luminescence material, sir. Is there any workshop regarding this field, sir, in further?
It is not. We are taking application wise. Okay, we are not taking. Can everybody mute themselves? Can everybody mute themselves? There is a lot of noise. Yeah. So Ajay, am I audible to you?
Yes, sir. Yes, sir.
Yeah. So we are not doing material specific workshops, but we are doing application specific workshops. Like if you have seen December, it was on quantum technologies, whereas this one is for sensors and optoelectronic devices. You can really test any material that you like. You can come. Okay. The idea of doing workshop is to brush up the fundamentals of the semiconductor devices and nanoelectronics, and then allow you to execute the project of your choice. So we are not planning a very specific workshop on those materials, but we are also planning application specific workshops. Is that fine with you?
Okay, sir. Okay.
Thank you.
Thank you. Sir.
Yes, sir.
Yeah, Karthikeya, please go ahead. You have a question?
Yes, sir. What type of technology we use in nano sensor and optic electronic devices?
Can you please repeat?
Sir, please elaborate in nano sensors.
Can you please repeat what you are asking? I'm unable to follow. Please speak slowly.
Sir, yes, sir. What purpose of this nano sensors and this optoelectronic devices?
See, optoelectronic devices, like say, suppose there are different types. Like say, suppose LEDs, right? Different types of organic, inorganic LEDs are there, where you use nanoelectronics to generate photons at a much lower cost and at a much higher power. Okay, that's where all the technologies are going. And it's a huge area of research in terms of conversion of, say, one side what you are doing, you are binding the solar energy into electricity, which is the solar panels, and the other side is that you are utilizing the electrical energy to convert into photons, right? So essentially that is what is one is the photovoltaics, and the other part is that it is the optoelectronic. These LEDs are LVRs, independent resistors.
Yes, sir. Basically,
yeah, please. Yeah, go ahead. Yeah, Kartikeya. What is your question?
yes, sir. Yes, sir. Basically, we works on photovoltaic and LED types.
Yes. So you will be given a hands-on exposure of the fundamentals and applications of LED and the solar photovoltaics. Okay. Is that clear?
Thank you. Yeah.
Good morning, sir. Myself, Rupa. I'm a research scholar at Kuvempu University in Karnataka. So basically, I'm working on optoelectronic devices. So I'm synthesizing using polymer doped films, sir. So I wanted to know, like, if I could do a small device, like basically a LED or just a PN junction diode, which is very, very like simple one. But when I went go through the papers, I will not find like in detail fabrication and all. So I'm looking forward for such kind of fabrication related things. So that's what I wanted to ask, sir. Thank you.
So you will be able to execute that thing. Okay. So you submit your proposal, you will be able to execute. Is that fine?
Okay. Yes, sir. Fine. Thank you.
Thank you. Bharat Kumar.
Hi, sir. I'm Bharat Kumar from Christ University, Bangalore. So I'm working as a faculty in Christ University. So if once my project is got selected, so for traveling to IIT Guwahati for 3 months is, I think it's quite difficult. So is it possible to send our students to IIT Guwahati for doing projects instead of ourselves?
Students will be difficult, but then you can come multiple times if you like.
Okay. So is it possible to send PhD students?
No, it is registered who has registered, the person should be coming. Okay, that's the rule.
Yeah, okay, fine.
Because that person only has gone through all the hurdles, not the PhD student.
Yeah. So that's what my doubt. So okay, thank you.
Thank you. Balaka. Balaka, are you there?
Sir, Deepak sir, good morning, sir. This is Malapat.
Yeah, Balu, yeah.
Rajan, audio is completely noisy. Next session, can you rectify that? Audio is completely, up and down fluctuations. So Rajan,
audio is fluctuating. Yeah, please don't make any noise. No.
From your end also, it's this noisy, sir. Next section.
Is it fine now? Is it okay now? Is it fine now?
It's okay, sir. Your picture is somewhat blurred, sir. I think maybe zooming thing.
Okay, we will work on it. Don't worry about it. Okay.
Okay, sir. I think Rajan.
Balaka, are you there? Balaka, are you there? Dayanand? So I just take up all the questions for this quickly because the next session is we are just shooting up time. So as I see the questions, sir, for the project submission, where is that? Sir, can you share? Yeah, we are going to share the PPT. It's very noisy. We are working on it. For the workshop. I mean, we'll try to accommodate all the ones who qualify. But maximum maybe 75 to 100, not more than that. I'm from IIT Surat. Is it eligible for offline workshop in the upcoming summer? Yes. Sir, you can share the PPT, you will get the PPT. Sir, selection criteria for offline workshop, you have to qualify for the quiz. Okay, and from there we are going to make a choice. I am from IIT Surat. Is it eligible? Yes, you are eligible for. Based on marks or how many numbers for offlines. See, how much is the question for the total marks? 100. Out of 100. Out of will be decided. Sir, for the project submission, if we specify about the design of some sensors, is that there is specific, is there any specific criteria that we should have more knowledge on some basic knowledge enough? See, everything you can, if you have some, if you do not have some basic knowledge, that can also you can cover. You attend the online workshops, you come for the offline workshops and discuss with the faculty members, you will be able to make up. Is it possible to submit an INUP project without a hands-on training? No. Okay, Mr. Chandan, Mr. Educational Research Institute. Okay, sir, I am currently doing project under DST parts on perovskite cells. Can I join offline workshop? You have to join the online workshop. You have to qualify for the quiz. Then only you can join for the online workshop. When can I submit the project? After completing the hands-on training, the final project will be submitted. But during the offline workshop, we are going to look at the first cut of the project. After completing the online and offline workshops, after completing or before, is before or after? It is after completing the hands-on. Okay, you will start after the offline workshop and you will finish after the hands-on training. You will get some real-time case studies. Please give us some case studies of real-time projects. You will get it, from all the speakers. Some clues for me. No, from me. Same question for me, sir. Okay, same question. The video is we are working on the video. Okay, it can be at your end also because we are tracking with our computers. It is quite clear. In our computer, it is quite clear. So it may be, at your feet. You have to look at you are having a high bandwidth. Where will you provide the link of the recorded sessions? You will be communicated. Please join the WhatsApp group. There you will be communicated on the sessions. When will you post the recording? It will be immediately done. So don't worry about that. In WhatsApp, the links will be shared. At INUP i2i website, report research proposal format is of 2023 session. We will update. As we progress, as we go towards offline workshop, we will update. Sir, can we apply for characterization of the material? Yes, you can do that, but you have to complete online and offline familiarization workshop. Sir, my background is detailed electronics, communication engineering, and right now my skill is embedded systems design. Will this workshop be beneficial? Yes, absolutely. Good morning, sir. Good morning. I am research scholar from IIT Indore. I'm interested in piezoelectric applications. Will this workshop be helpful? Yes. You will develop a SAW device on your own. Okay. So with this, I think we have answered most of the questions of yours very, very comprehensive manner. I just request Akshay to say a few words before Roy can start. Thank you so much. And any other question you have, you can drop in the chat box. We will be answering. Okay, and we'll take care of it. Thank you so much.
Sir, sorry to disturb you. Myself, I have a small doubt. So I have already underwent the INEP training program offline as well as online both, and my project is selected in IIT Madras. So they don't have all the facilities like time for my polymer sample to do. And can I just contact you through mail or any other mode for further? And part of the work I can do in other IIT branch and your branch. So is it possible?
So you request IIT Madras, you write together IIT Madras and us. Whatever you have told me, you do that writing a common email to IIT Madras as well as us. Okay, we are going to internally discuss and get back to you.
Okay, sir. Sure. Thank you, sir.
So much.
So much, sir, for the detailed informative talk and for taking up all the questions our participants had. Now we would like to request Professor Akshay Kumar sir, the head of Center for Nanotechnology, to introduce us to the Center for Nanotechnology and the facilities available at IIT Guwahati.
Okay, good morning all. Welcome to this online familiarization workshop of this edition, the second in this edition. So we are running out of time, but then I will quickly tell you about some of the facilities that are available here and how you can benefit from it. So I will not show you any presentation. I will take only about 5 minutes. So the Center for Nanotechnology at IIT Guwahati was established in 2004. We have a group of faculty working across disciplines, and our current strength is about 23 faculty, and we have faculty working in chemistry, chemical engineering, mechanical engineering, electronics, and so on. So this has given us the required expertise to work across fields. So, for example, with respect to the current online familiarization workshop, you see that this is on sensors and optoelectronic devices. So you could just envisage that faculty who are working in chemistry would come up with expertise on the organic molecules which are used as semiconductors, whereas the electronics faculty would help in designing the circuits, and then faculty working in the area of computation would help in doing the necessary, the design of devices and the validation of the prototype that is developed and so on. And apart from that, we have several staff who are helping us with the day-to-day activities, organizing this workshop, compiling the data, right, and then taking care of the logistics that are needed. They are also helped by the INUP staff also. So most of the details about the center you would get when you personally visit us here. I hope that all of you would take this online workshop very seriously and listen to all the lectures with great attention so that you can do well in your quiz. And this would definitely help you in scoring good in the quiz that is conducted. So with that, you could actually visit us at the at IIT Guwahati, which is a very beautiful campus. And the time of your visit also would be the time when the weather is very pleasant. So we look forward to see you all here. The facilities at the center, Professor Dipankar Bandyopadhyay has already detail you on the various facilities that are available for both fabrication as well as characterization. We have ISO 5 and ISO 6 clean room facilities as well. So apart from the various laboratory facilities where you can do the initial synthesis and prototyping. So with this, I wish you all the best for the workshop here. Listen to all the lectures. The lectures are a very good mix of technical writing and fundamental understanding on the basic techniques, as well as it ends with the quiz. And your performance in the quiz is key for the future progress in this version of the INUP i2i. And with this, I wish you all the best. Do well, and look forward to welcoming you all at IIT Guwahati for the future stages of this workshop. Thank you.
Thank you, sir, for the brief introduction. We have now come to an end of the inaugural session. We extend our gratitude to all the speakers for their valuable time and successful completion of the session. With this, we would like to move ahead and start the initial session of the day. First, we would like to invite Professor Roy for his talk on devices for the detection of breath components. Professor Roy received his BTech degree in Electronics and Communication Engineering from the College of Engineering, London, in the year 1990. MTech from IIT Kanpur in 1996 and PhD from IIT Madras in 2004. He is currently a professor at Department of Electronics and Electrical Engineering and is an associated faculty member in the Center for Nanotechnology and the School of Health Sciences and Technology, IIT Guwahati. His research interests include VLSI devices, circuits, and maps. With these brief introductions, I would like to request Sir to commence the plenary session. Over to you, sir.
So Rajan, am I audible and visible?
Yes, sir.
Yes.
Thank you. Thank you. So today I would like to talk about devices for the detection of breath components. Obviously, all of us learn from others. So I learned most of my research topics from my students and my teachers. And there are a lot of people supported us in this journey, that is MIT, Government of India and other FAB facilities. This work is basically done by one of my research scholars along with the other research scholars, Thomas T. Daniel. His picture is at the top. So this is how I organize my talk. Breath gas analysis, little bit of literature survey, and materials. Then three different devices. One is a printed Sedano resistor for this analysis, breath gas analysis. Second one is a magnetic material that is also a resistor device, resistive device. Third one is a semiconductor magnetic material based resistor for again the breath analysis. That is how I organized my talk. And if you look at the breath analysis, or we can call it breath biopsy, you know, Nobel Prize winner Linus Pauling, he received a Nobel Prize for two entries. The one is chemistry, later for peace also. He highlighted that exhaled breath contains hundreds of different, he is numbering something like over 200 volatile compounds. So these volatile compounds can be endogenous metabolites or exogenous compounds, and also there is also VOCs will be relatively smaller particle, but there are also larger particles coming out of breath, present in the breath, that is respiratory droplets like proteins, viral DNA, RNA, drugs, non-volatile metabolites, etc. So now, if you look at some of these components which is present in the breath, is going through, this is a good marker, and since it is a good marker, many clinical trials initiated. And for example, to detect capnography or maybe neonatal jaundice can be identified with the presence of CO, and asthma with the presence of NO. Smokers, obviously CO will be present, and roadside intoxication test, ethanol. So all those things are already approved breath test. And so the main three gases, if you look at which are approved for the breath diagnosis, are CO2, CO, hydrogen, and nitric oxide. So some of these gases we would take up as a part of this study. So now, before we start detecting something, first of all, we should know what is our range of interest. For example, nitrogen presence is too much in the air, and oxygen and all. So we should know, for example, if you want to detect hydrogen, typically what is the normal levels of hydrogen in our breath, that we should know. So this report, this table summarizes that hydrogen levels are typically high in breath gas, and the CO levels are also high in ppm. So is it okay, Rajan? I mean, things are okay, no?
Yes.
चेक कर लेना चल रहा है कि नहीं इस वाले बोर्ड पे ना.
Participant, mute yourself, please.
Yeah. Okay. So the CO levels are in ppm and NO levels are in ppb. That is what we can notice. So if we are making a sensor, we should making an NO sensor, we should be able to detect in ppb levels, part per billion levels, and the CO in ppm and the hydrogen high levels. So now presently, if you look at what are the techniques available in the market, I mean, these are some of the techniques, and gas chromatography based on mass spectrometry, and proton transfer reaction mass spectrometry, and other ion tube mass spectrometry. These are some of the methods, and ion mobility spectrometry, etc. are used. These are obviously bulky and costly. So what we are aiming is rapid, low cost, enable whole body blood sampling, non-invasive and pain-free, point of care for a wide range of diseases. Once we are able to bring this low cost and multiple analyte devices, we will be able to extend easily to multiple, to all social sections. That is the idea. So now literature, if you look at it, I'm not going to dwell too much on this. This is a big summary. The details can be found in the thesis, PhD thesis of Thomas Daniel. As I mentioned, there is a reference given at the end of the talk. These slides will be made available, the PDF form of these slides. So you can refer it later. But what I want to say is that typically, conductivity method is used for chemiresistors using conductive polymers, chemiresistors using graphene or carbon nanotube composites. There are hybrid structures also. Each has its own plus and minus. The last column gives you what are the VOCs and gases already studied, detected. And each method has its own advantage and disadvantages, which are summarized in this slide. So again, surface acoustic wave devices is another angle where we measure the frequency and the frequency shifts. And optical methods are there, change in light parameters, optical parameters. And quartz microbalance is another thing which will detect mass change. And also transistors are used actually, threshold voltage change, current change, etc. And also MEMS devices are there. And so this is this list summarizes different devices for detecting different VOCs and gases. Okay, so now the materials, as I mentioned, in this talk, we want to highlight that we use both the semiconductor and magnetic material. So if you look at the semiconductor devices, there are inorganic material, there are organic material. So organic material have their own unique advantages, and in some of the talk you will be listening to devices based on organic material. But inorganic materials also has its unique spectrum, as you know. They are popular because they are very stable and their mobilities are better. So Isodeno seems to be a popular device. One issue with Isodeno is it's a wide band gap. Wide band gap means it's not very easily. I mean, the electron, electron may not. We will not be able to excite electrons very easily at room temperature. You need either high temperature. I mean, that is why you find most of the gas sensors are at high temperature, operate at high temperature. If they operate at a high temperature, what happens is typically 400 degrees centigrade and all, you need to provide battery power. You need to heat a filament and bring the material to that temperature so that it can detect the particular analyte of interest. So a lot of power is consuming in this process. So that is a disadvantage. So what we are aiming here is room temperature. All these sensors, so what I'm talking today, all these sensors are operating at room temperature. So that is one of the aim. In order to do so, you need either a UV excitation or a temperature assistance, or we form nanoparticles and nanostructures. That is another way you can overcome this difficulty. That is what we are going to see in this presentation. And the second material what we chose is magnetite, that is magnetic oxide. It is a very popular material, and it is also stable, and it's available plenty. So one property what we use there is in magnetite, Fe3 plus and Fe2 plus both are present. So I mean, these ions with its own polarity, it can attract analyte ions. So what happens is, in a system of Fe3 plus and Fe2 plus, one of the concentration can increase or decrease. For example, Fe3 can increase while Fe2 can decrease, or the other way. So what happens is this will bring electron movements, electron flow. Change in either number of electrons will be increased or number of electrons will be decreased, though that will constitute a current. That is the basic idea here. And that is, so mainly the property we are looking forward is the Fe ion distribution in magnetite. Also, finally, we also wanted to combine magnetic and semiconductor material. For example, in the magnetite, we incorporate a zinc. So it becomes zinc ferrite, sudden Fe2O4. So the advantage here is now it has Zn 2 plus ions and Fe3 3 plus ions, and also some Fe2 plus ions also. So now you are making the reaction, or you will be able to find more analytes suitable for the reaction, and you can create an electron idea in this work. So combining semiconductor material and magnetic material give you a lot of advantages and a lot of flexibilities and advantages from both the worlds, and magnetic world as well as the semiconductor world. And these properties can be exploited for the detection of breath gases. That is the idea here. So now this is something more physics behind the. So these are the typical structures for Nano and Fe3O4 and zinc Fe2O4. And I mean, these are available in the literature. Basically, because of the structural differences and where Fe2 plus ions and Fe3 ions are occupied, this matters, and that is what controls the reactions and things like that. So that way, this is what is fundamentally changing, and these differences are causing the making it as a sensor. So now, once you look at the material, I mean, if you look at this material list, this is the entire list of material we used in this study. Most of this material, 90% of these materials are can be easily synthesized in a laboratory, in a chemistry lab, or in a biology lab, or in a normal tabletop arrangement. You have some clean water and a small heater and things like that. So these are not very costly way of making devices. One, even though IIT Guwahati, we have this lithography facility and other instruments and all. As far as possible, if we can make good applications from basic sciences, that is something good, isn't it? I mean, we need not take the route of lithography, etc. So all those materials are typical chemicals which you can purchase, and you can, for example, silver nanoparticle ink is a conductive ink we used, which is for contacts, and Fe3O4 obviously, and also sudden Fe2O4 sudden structures, and also sudden ink also prepared by normal chemicals. But we need to buy some gases. No, the typical three gases we focused in this study are NO and hydrogen and also nitrogen. So we need to procure those cylinders at a particular concentration, like 100 ppm NO and 5% hydrogen cylinder, high purity nitrogen gas cylinders we procured, and these are small cylinders, and that is how we conducted this study. Okay, so now let us go to the first work, that is printed Nano resistor. See, I want to highlight the term printing. As I mentioned earlier, the typical lithography-based top-down method has its own advantages and disadvantages. All are required. All the ICs are fabricated by that method. But you know, there are a lot of chemicals required, a lot of energy required. It's a very costly affair. A lot of equipments are required. It's more time consuming. So, but that way, compared to that, nowadays, printing technologies are gaining a lot of attention. Printing technologies have a lot of advantages. They also can be fast and highly automated. A large scale production, it can be scaled up. They are also precise, may not be as precise as lithography based technique, but their precisions are improving. And incidentally, the device what we are talking about need not be in nanometer dimension. It can be in micrometer dimension. No, nanometer features are there because we are incorporating nanoparticles, etc. But the length of the device, etc., can be in micrometer. So printing is handy. That way, it is very useful. And also, you need to remember one thing is that to make some nanometer devices, you need to establish a clean room and a facility, fabrication facility, which is also very costly. India, as you know, India is now trying to develop a nanometer level fabrication facility with a lot of government funding, and a lot of parties are invited, and talks are going on, and something is going to come up very soon in the country. So that way, laboratory level and all for educational institutions like us, this printing technology seems to be a good option. So it's environmental friendly, not much material waste is there, and things like that. And typically the cost will be low. You will be using very small amount of material in this case. Okay, so now we employ two printing methods in this study. This one is silver. If you can see this figure A, there are two contacts, one using silver nanoparticles. They are big size. So why we keep big sizes? Of course, if you increase the size, the contact resistance, etc., will be lesser. That is one reason. Second, but that is not the only reason. The main reason is we want to take wire connection from that parts. Because then only we will be, if you make a resistor, you know, you need to take contact out of these contact leads, and you need to connect it to the measuring instrument and check it, isn't it? So that is the idea. That is why we make it bigger. So this is a printed 5 micrometer printed Nano, which you can see at the middle black portion. I don't know whether you can see my cursor. I'm moving my cursor. I hope you are able to see that. And also, there is you can put a drop of Nano ink. So obviously, as you can intuitively see, if I print it, the thickness of the layer will be less. If I make a drop, obviously the thickness is higher. So I can do more things, like I can do multiple printing. If I do one printing, give me, let us say, 25 nanometer thickness. If I do two printing, maybe I'll get 40 to 50 nanometer thickness, or maybe three times printing, 4 times repeated printing, I can increase the thickness also, which is something which we have employed in this study. Okay, so now let me go back to the devices which we developed. As you can see, the developed devices, this optical image indicates that their dimensions are in micrometer, not in nanometer, but they are good enough to detect these breath gas components. That is what you can see. The FESM image shows that there is a Nano channel and the silver nano particle contact parts, which is big. There are some residues and all which you can see because these are all typically developed in the typical laboratory settings, and so you can see some residues, etc. Some structures, and the XRD indicates they are Nano, and we plotted the semi-log IV. That is what typically electrical engineer or physicists do. Once they make a resistor or a Schottky diode, they will do the IV and they will try to fit with the non. This is a Schottky diode characteristics which you can see, and you can see the IV fitting, and using the typical thermionic emission model, you can fit it using that basic equation. So if you plot ln current versus voltage, you will be able to get the ideality factor from the slope, and that is what is indicated here. And also you can also plot include the contact potential also into the equation, and you can plot HI versus current, and you will get the details about the sheet resistance, typical sheet resistance obtained for the device. So we are talking about 3 devices here. We made multiple devices. So these 3 devices are summarized here, and even this D1 also we made multiple devices. So we just take a representative sample from D1 and D2 and D3. D1 is sudden spot is printed between contacts, like in the earlier figure A I showed you. D2 is additional sudden spot is printed over the annealed printed spot. Means I did a one-time printing, and I did after annealing, I did a second printing. Means the thickness is increased. So if you see this table, the thickness of D1 is 150 nanometer. If I do one more printing, the thickness is 390 nanometer. So that means thickness is almost doubled, slightly more than double in this case. So once the thickness increases, the type of device with less thickness, we have a Schottky diode. As I increase the thickness, we have ohmic device. And obviously, if you increase the thickness further, D3 is drop casted. So the thickness is obviously more, above 400. And that is close to micrometer level. So that is what is ohmic contact. So we have, by simple printing, we have initial printing, we have Schottky, and then we have ohmic, because this thickness dependency on the contact barrier height and all is well studied, and it is available in the literature. This is a non-phenomenon. Okay, so now, Rajan, please remind me before 5 minutes or so. Yeah, please.
Yes.
Okay, so now we developed also a gas testing facility at IIT Guwahati. I mean, typically, if you look for a gas testing facility, it is very costly. So some of our students, Dr. Gayatri and Dr. Thomas and Vimal and many people were involved in this developing, and we got it fabricated outside, and this is a low cost in the sense you need to spend maybe around 30 to 40 lakhs for this gas testing system. There is a software which will analyze and give you displays. Basically, it contains some MFCs, mass flow controllers, and 1, 2, 3, and by which you can, there is a PID controller here, and there is a chamber. It's better to keep the chamber volume smaller, so that way you, with less gas, you will be able to do a lot of work. So we did, using this gas testing facility, we measured the sensitivity of Sedano resistor which we made. I mean, D1 is not resistor, D1 is Schottky, D2 is resistor, D3 is resistor. So we measured, we found that the Schottky device gives you better sensitivity towards CO. So that is also reported in the literature. Schottky devices give you better sensitivity. That is what we can see here. But since we made these devices, We also need to check it against the selectivity studies we need to do. The typical component present in the breath gas, we need to check whether this particular sensor is responding to only one analyte or multiple analyte. So we can see that from this study, CO is what we want to detect in this case. CO, it is giving higher sensitivity, but there are responses, for example, ethanol and acetone, etc. It responds, but the response is not as high as CO. And the nitric oxide and hydrogen and all, it is not at all responding. So, which is a good thing. Basically, things are under a little control, not completely under control. We would have been happy if this would have responded only to CO and not at all responded to any other gas, but that way life is never simple. You need to work with what you have, and but at least good sensitivity is obtained towards CO. That is what we can see. We also did a transient response. A transient response means I apply the gas CO 1 ppm, 10 ppm, 20 ppm, 30 ppm like that. And I switch off the gas and I want to see whether my device is changed or not. See, by the absorption of CO, if the device is changed, I will not be able to use it for second measurement. But in this case, I can see that whether you apply 1 ppm or 20 ppm, finally device comes back to the same current level and you can reuse it. That is the advantage you can see here. So this curve will look a little noisy and all. That is because you are switching on the gas, switching off the gas. These things are done manually. MFCs are there, but so it's a small chamber and all volume, get disturbed. That is why you see some transient kind of some noise kind of a behavior. But anyhow, one thing is sure. If you increase the concentration, your current levels are increasing. That is one thing. Second thing is, if you switch off, when you switch off the gas, it is coming back to the same baseline. That is what you can observe here. So now we made a comparison. You need to make a comparison of our work with reported literature. And what we can see is that printed SNO is you are able to measure the CO concentration from 40 ppm level. ppm level is what we are interested also, and sensitivities are very good compared to the literature. The main thing is it is a room temperature sensor. There are other sensors also room temperature, but this one is also room temperature. That is the advantage. So now let me move to the second. This is published in ED, IEEE EDL, and this paper is available for download, and you can check for details. So one highlight is this is printed one and room temperature sensing and using the normal chemicals which are available in the lab. That is the advantage. You can make Schottky as well as you can make ohmic sensors, resistors. So now let me move to the second work, that is magnetite-based resistor. Magnetic materials we employed. So this time we used a little bit of lithography to define the contact points, aluminum contact points. This is the cross-sectional view, top left one. We started with the silicon dioxide wafer. Our aim was to make a FET later. That work is not discussed here, but anyhow, that was the intention. That is why we went there. We used magnetite-based microspheres. MS means microspheres. Typical channel length is 20 micrometer. And this aluminum and silvering, aluminum is deposited. Aluminum is defined by lithography, and in between, we place this magnetic nanoparticle. This is the top view, the second figure. And we did the TEM analysis and selective area, electron diffraction image, and we observed the fringes and figured out what is the plane orientation and how is the clustering, etc. The detail, what is the size of the microspheres, etc. You can see they are around 500 nanometer size. So now we also did FTIR and powdered XRD and magnetic moment studies, and because this is magnetic material, and that is what we did. Again, the sizes and the surface terrain and details are there. Which planes are visible, those details are there. Its transmittance results are there. So the main electrical characteristics are summarized in this figure. See, there are three devices here in this study. S1 is microsphere treated with NO. Microsphere, when NO is exposed, what happens? S2 is high synthesized microsphere. No NO, no nitrous oxide exposure. And if S3 is nanoparticles. See, that means S1 and S3 all are ferrite magnetite based resistor, but one is a nanoparticle size, another is a microsphere size. So we found that, if you look at the microsphere one has the highest sensitivity. So that is why we used but the nanosphere, nanoparticle based one sensitivity is very less. So we prefer to use microspheres in this case, and NO, NO2. So one bad thing is we want to detect NO, but one issue is that it is responding to NO2 also, which is expected, but still, it is slightly less sensitivity, but still that is one disadvantage, or you can say that that is one issue here. And also the second issue, whenever we make a device, we need to check whether they work across all humidity values. So this is also up to 70% or 60% humidity, things are okay. But above 60%, 70%, the current is increasing just because of humidity, not because of the NO. So this is also, so if at all we need to use the sensor, we need to use a very controlled environment with the controlled humidity and all. That is what is the lesson here. So, and also there is a hysteresis present, that is true for any magnetic materials, and those studies are conducted for this. So now we also did the transient response, and see, in this case the current is decreasing if I increase the concentration. That is what you can see. And each time, once you cut off the gas, each time the device is coming back to its base current level. So we can reuse the device again, and the sensitivity values are slightly changing when you change the oxygen-nitrogen ratios. So that is something which we observed, not very noticeable. So typically, that is also some study we conducted to check whether the sensitivities will be different or not. Okay, so now this work also we summarized with other literature which are available. There are many work for NO detection, and our work is this last one, the last row in the table, and it is giving decent sensitivity, and also the response time also is comparable, and the NO concentration we are able to measure at the ppb levels, and this magnetite we used maybe for the first time. So that way, this work is also, we published this work in IEEE Sensor Journal, and so now this is a magnetic material based, and especially microspheres responded well than nanoparticles. This is room temperature sensing of NO at the ppb level. So there is no structural variation when it is exposed to NO. XRD pattern, etc., indicate the recovery process and the transient response. So due to the magnetic moment changes, and it shows a high sensitivity. Okay, so now let me come to my last work, which is presented in this talk, magnetic and semiconductor materials combined. So again, in this case also, we used a little lithography facility for contact parts, which is not mandatory that you should use a lithography facility. We can use printing also here. Still, you will get the same results. And this is the optical image, and as well as the FESEM image, and you can see a lot of grain boundaries, a lot of scope for surface area, and a lot of scope for reactions. And we did XRD and FTIR spectra for A1 and A2. The difference between A1 and A2 are A1 is sample treated with the hydrogen. In this case, we want to detect the hydrogen. I mean, if you can notice, we want to detect hydrogen, NO, CO. I mean, 3 different gases we are reporting. So in this case, the last case, it is hydrogen. So A1 is treated, I mean, when it is exposed to hydrogen, and A2 is when it is asynthesized resistor. So in this case, you can see that if I increase the concentration, the bare wafer, bare resistance, when there is no zero exposure to hydrogen, the current is lowest. And if I increase the ppm hydrogen concentration in part per million level, its resistance decreases and current increases. That is what we can see. And this is the average electrical resistance plotted, and also the sensitivity. We could see that the combination now compared to ZNO alone, the combination gives you better sensitivity. ZNO magnetic plus semiconductor material combination gives you better sensitivity. But again, there is something you need to note down. You need to be careful because this is a temperature dependent process, the resistor. So if at all you need to employ this sensor, you need to keep it in controlled temperature environment. That is important. And this is room temperature sensing, but if I change the temperature by somehow, its resistance shifts. So that is something which again the humidity also affects it. So we need to operate it at some good humidity level where things are constant. And again, we checked for the selectivity studies. How does it detect other than hydrogen, other breath components present? So we could see that it respond, unfortunately, but the response sensitivity is much better for hydrogen. And even if I put hydrogen and CO2, ultimately we are getting similar sensitivity. That is what we can see. And the transient response shows that current increases with ppm levels of hydrogen, but always it comes back to the base value, so we can reuse the devices. So this is the summary. ZNO Fe2O4 ZNO based magnetic sensor is fabricated to detect hydrogen in ppm levels at room temperature. And the hierarchical structure, this structure was synthesized using a normal solvothermal method, and fabricated MS sensor exhibit much better sensitivity and faster response toward hydrogen gas at room temperature due to the combined effect of magnetic and semiconductor behavior. This paper also published in IEEE sensor. This is the summary. You can see that this is the summary of all the 3 work. In the first row, you can see that it is a Schottky diode which give you best sensitivity. It is a fully printed device. Silver nano particle is the electrode. ZNO is the channel material, and the device we tested all these environments, and the primary gas was CO. Primary gas concentration was this. This is the response time and recovery time. This is the sensitivity. The second device which we discussed is a magnetic resistor. Metal contact alone we did using lithography, but it is not mandatory. That also could be printed. And channel material was drop casted, and electrode material was aluminum in this case, and channel material was this. These are the environment where we tested ppb level detection and sensitivity. The final one also is a resistor. It's a semiconducting magnetic resistor, you can call. And again, the metal contact was lithography, but it was not mandatory. You could use printing also. And this is the channel material. And this is the varying environment where we are tested it, hydrogen we did. So basically CO, NO, H2 in the level, I mean, we are interested in these levels, and because of this, in this level, in the breath gas analysis, these levels are important. This range is of important, and we are getting in seconds the result. Within a minute, the measurement is done, and you have a decent sensitivity. So that is the summary basically. So this is an initial work basically. See, you can extend this work basically to people connect with different breath gases, gases present in the breath to different body organs and their functioning or dysfunctioning. So this is a very interesting area. This information is from a lot of studies by medical people as well as researchers. So we can develop slowly one by one devices, and this will be useful to the research community. And some of these devices, if they are performing well, they can be translated also into products. Okay, thank you.
Thank you, sir, for your informative talk. We will now begin our Q&A sessions. There are two questions in the chat box. One from Neelam. Sir, can I use the MATLAB simulation software in this project for designing?
For example, you have a thermionic current model for Schottky diode. So you can use MATLAB. Obviously, you can use. But if you want to, I mean, if you want to know about whether NO absorbs in this particular material and such studies, you may need some other softwares. Atomistic fundamental studies, DFT studies, and or if you want to know more about these are resistor symbols, so you don't need a very particular device simulator software here. MATLAB can be used for basic equation modeling. Yes.
So the next question is from Manjeet. He's asking, so the zinc oxide ink absorb the CO? If NO is off for how much time it remains in zinc oxide nanostructure?
Yes. That is why these studies are important. I mean, if you notice in my presentation, within few seconds, I mean, you allow, for example, NO you asked specifically. So let me go to NO. This is NO. So 10 ppb levels, and within let us say minutes, it is completely deabsorbed. So you can see the x-axis here, 100 ppb, and it came back very soon. Actually, if you notice the slope, here, I mean, this slope is very sharp, isn't it? As soon as gas out is there, it comes back very quickly. So within 10 seconds, 20 seconds, it comes back. So that is your answer. How long? Yeah, 10 seconds, let us say. Yeah, yes.
The next question is from Urugeshwari. She is asking about the solvothermal method. How to go for a lithography in making the devices? Please elaborate the process of making the devices from progress app.
Yeah, so you can use either, I mean, lithography helps you to pattern the devices, no? For example, I want a contact electrode, which is rectangular in shape of, let us say, 100 micrometer, 100 micrometer. So I make the mask corresponding to that. So I don't know what is your background, Murugeshwari. If you are already familiar with some INUP workshop and hands-on training, you will be taught these aspects and how to make a device and how to use lithography and all. So if you have good background, let me summarize. If you already exposed to that, solvothermal is preparing these nanoparticles and channel material, no, in a chemical way. using liquids and heating and two chemicals added and things like that. That is a simple method. There is no lithography there. But lithographically, you can deposit material and lithographically pattern it later. For example, you deposit everywhere, then you etch the material except from the channel somewhere. That is how you use lithography. I hope this answer is okay. Or if you want to know more about it, we can discuss it in any one of the hands-on training workshop or more detailed way. Yeah, thank you.
So the next question is from Abha. Sir, how do we narrow down to what type of material we are using for the sensing application is specified for us?
Yeah, that is a good question. See, initially, no, when we started the experiment, we thought we use the same material for detecting multiple gases, and it should be very sensitive as well as very specific. But you know, life doesn't work like that. So our aim was not to use 3 different materials at all. We started with this Nano. If you'd have detected all the other gases with this Nano itself, things would have been better. But at room temperature, it doesn't work out. That is why we need to move on to magnetic material and magnetic semiconductor material. So your question is, how do we know? How do we narrow down? See, one thing we did is we did a literature review. What material, what gas, what is available in literature, what other people did. See, our group, we are basically from electrical engineering, collaborating with some colleagues in nanotechnology. So we are not very strong in chemistry, our group, but we have a lot of chemists, very strong chemists. So they will be able to help us in this matter. Okay, this material will be useful for this. They study those aspects in detail. Nowadays, you know, there are simulators also. People do some atomistic level simulation work, and you will be able to figure out what work to find with the other material. So how we figured it out is we did a literature review. Some reports are there, may not be a device level detected, but maybe some reaction happening in animals and things like that. We looked at literature, and these details are given in the motivation section of the paper. How did we narrow down to this particular material? I mean, for example, NO case in mammals and all, it's this reaction is popular and known. That is why we thought magnetite will work better with that and things like that. Yeah, hydrogen also, for example, magnetite again with this zinc present. So that is how we came to know for that it might work.
So the next question is from Vivek. Sir, can we use DC RF sputtering method for deposition of silver metal contacts?
I think so. DC sputtering, I think so, because silver nanoparticles are not difficult. You should have a source, and typically thermal or sputtering. There are other methods. There is no problem. They may be better also. There is no issue. What we wanted is a very quick solution. I mean, you have silver nanoparticle ink in a bottle, and you apply the paste, and you have a contact. So you can use any other deposition method. So some materials are difficult thermal evaporation. You use sputtering, and some are thermal evaporation or E-beam evaporation, etc. Any method you can use it. Yeah.
The next question is, what are the prerequisites for this field?
Can you scroll up? I did not get Rajan. I can scroll up. Yeah. What was the question?
What are the prerequisites for this field?
Yeah. So prerequisite is, I mean, I feel you can be a physics student or a biology student or even an electrical student, but you should be willing to expand your mind a little bit area, no, to accommodate some other area also. Like if you are an electronic student, you need to learn a little bit of chemistry and things like that. Little bit of reading about the medical journals, what gases are present in breath and what kind of studies are done, what works. Or if you are a biology student, you should be willing to expand a little bit to electronic side. Okay, diode, what is it? What is the basic equation and or a resistor, how does it function? I mean, it's not a very big prerequisite is not really required, but if you have a lab where multiple students work, like chemistry students, electronic students, biology students work together, in such a lab, always there will be an advantage and you can find help always. Yeah. That is how these workshops also helps you. You make friends and you talk to people and our work also, if you look at the other list, there are chemists in the group and there are electronic students. There are multiple people here. Yeah.
The next question is from Vishal. Can we also use these resistors in droplet-based microfluidic system as well?
Droplet-based microfluidic system. I I don't know. I mean, microfluidic system means we create a channel and some liquid flows through that. But I understand that way. But why do you need a resistor there? Which I don't know. Probably yes. I mean, this printed resistors, droplet-based resistors, you can deposit in any surface. So if there is a micro channel and some fluid is flowing, and at the bottom you want to create a resistive patch or something, probably you can use it. We need to check the reaction of these materials with the fluid which are there in the microfluidic channel. And there should not be any reaction, something like that. If there is a reaction, you need to passivate it, or you need to make a passivation layer so that there is no direct reaction, but the resistor is protected. Or so I actually I don't know what is the specific application in your mind. So we need a little discussion to understand this. And but I would say this can be employed in multiple systems as well. Yeah.
Sir, we have multiple questions in the chat box, but due to the time constraint, I would like to request you to kindly answer them in the chat box itself.
Yes.
Thank you, sir.
Thank you.
Now we will take a small tea break of 15 minutes and we'll continue the session from 12:25 onwards. Thank you.
Hello, Arun. Yeah.
Sir, questions are not going
Okay.
Unmuted.
Salil sir, are you there online? Salil?
I'm there, Arun.
Yeah, so can we, if you want, we can
Share.
check your slides once. Yeah.
Yes, yes. So I'm audible, right?
Yeah, you're perfectly audible.
So I've shared the slides.
Okay. Yeah, it's perfectly visible. Just scroll 1 or 2 slides up and down.
Okay, one second. Sorry. It is
It's not
working,
full
right?
screen. Yes, yes, it is working fine, but you can make it full screen also.
Full screen now.
It's not full screen for us.
Or is it?
So maybe you can try sharing the screen instead of the file itself.
Acha, acha. Okay, okay. 1 second.
Then maybe we'll get the full screen.
So I should share the screen. Is this full screen now?
Yeah, now it's full screen. So we can start in 5 minutes.
Okay, okay, sure.
Okay, okay.
Welcome back everyone to INUP i2i Familiarization workshop. Before we move on to the next session, we would like to thank Professor Ayapalli once again for his valuable time for answering all the doubts.
Now, we would like to invite Professor Salil Kashyap to talk on how to write and structure a journal paper for publication at high-impact venues. Dr. Salil Kashyap is an assistant professor in the Department of Electronics and Electrical Engineering at IIT Guwahati. Before joining IIT Guwahati, he was a senior DSP engineer at Marvel, where he designed physical layer algorithms for next-generation WLANs. Prior to that, he was a postdoctoral researcher in Linköping University, Sweden. He received his PhD from IISc Bangalore, MTech from IIT Guwahati, and BTech from NERIST. His research areas include wireless communications, network, and signal processing, with emphasis on mathematical modeling, performance analysis, and algorithm design for 5G and beyond 5G cellular communication systems. With this brief introduction, I would like to request Sir to commence the session. Over to you, sir.
Yeah. So thank you so much for the kind introduction. So today I'll speak on basically how to write and structure a journal paper for publication at high impact venues. Yeah, so essentially how to write a journal paper so that it is suitable for submission and eventually acceptance at good venues. Hope I'm audible to all.
Yes, sir.
Yeah, thank you. Yeah. So what I plan to do is I plan to discuss for about 35-40 minutes, and then I'll be very happy to take up questions and interact with the participants so that if they have some specific queries, I'll try to address. So this is roughly the plan of the lecture. I'll essentially try to give my perspective on the topic. Yeah, so we'll start with looking at why should you really worry about publishing at good venues which have sort of high societal impact. What should typically be the structure of the journal paper? Yeah, so I try to give a generic structure that should sort of fit, cover all areas of research. How should you really find the appropriate venue to submit your manuscript? I mean, given your field of research, how should you really decide where to submit? We'll also look at little bit in detail about the peer review process. So when you submit a manuscript to eventually acceptance and publication, what are the different stages that a manuscript undergoes? We'll look at an essential part of peer review process, which is how to prepare response to questions raised by the reviewers and the editors. Yeah, so I feel these are all connected questions, and they help you address the broader theme. Now, coming to the first question, why should you really care about publication at good venues? The first and the foremost reason is it can open bright avenues to go up the academic ladder. I mean, not just academic ladder. If you are in a research position in the industry, if you publish regularly at good venues, it sort of gives you recognition for the science that you do among your peer group. If you have publications at good venues, it will most likely help you attract prestigious grants and research funding so that your research is supported. Yes, so this is like a byproduct. If you are able to attract grants and research funding, eventually you will get promoted, and you'll go up the ladder in the career. If you publish at good venues, you can, I mean, you can essentially, it gives you a chance to collaborate with renowned research groups who are like working on similar topics as you are. Yeah, and so overall, it has to do with gaining recognition among the peer group and for the science that you do. For the yeah. However, one should also understand that if the objective is to publish at good venues, it has its own set of challenges. One should be very careful about the problem that you address. you should write at the beginning. You should make sure that the problem that you are trying to address is relevant and is well motivated. Yeah, so there is enough thought put to formulating the problem, because if the problem is well formulated, yeah, people generally consider half the problem is solved. So the problem addressed should be both relevant and well motivated. Not just that. Uh, yeah, so by well motivated, I mean you should be able to convince why this problem needs to be addressed. What will be the potential implications if this problem is solved? Yeah, will it essentially answer a long-standing query, something that was not resolved for a really long time? Are you going to address that? The solution that you propose should be new. Yeah, it has some. It must have some new aspects. Yeah. The solution that you propose should be non-trivial. What do I mean by non-trivial? There should be some challenges that you may have tackled in order to solve the problem. Yeah, it should be analytically involved. Yeah, so if your research is mathematics based, then you must have used some new analytical tools in order to solve the problem. Or if you are from the circuits background and your concern is about fabricating a chip, then the modeling must be unique. Yeah, it must be very different from what is there in the state of the art, and not just modeling the design methodology, and eventually once you get the fabricated chip, the performance that you measure should should be better than what is there already out in the market. Yeah, so so to summarize, in order, I mean, for you to be able to publish at good venues, you should essentially ensure that the contributions that you make, yeah, in terms of new results, in terms of modeling, in terms of system design, or if you're developing an algorithm, the algorithm is sort of optimal and at the same time computationally simpler. So the contributions have to be substantial. They have to be significant. Yeah. The other challenge is that most of these good venues have a rigorous peer review process. So essentially, when you submit the paper, so we will have a separate discussion on this peer review, but just to give you an outline. So when a paper is submitted, it undergoes rigorous review process. Generally, there will be 3 to 4 reviewers who will sort of carefully examine your work, and they will, I mean, most of the times the feedback is constructive. So that if you revise your paper based on the comments that you receive, the quality of your manuscript does improve. Yeah. So the peer review process is rigorous. Yeah. Most of these good venues have low acceptance rates. So by acceptance rate, I mean the number of papers that get accepted to the number of submissions that a particular journal receives. Yeah. So so it's a famous saying that getting a journal, you might be working on a problem for a long time, and let us say you have the solution to the problem, but unpublished work is is no work done actually. So whatever results you obtain, they have to be published at the venue. It has to undergo a rigorous peer review process. So one can essentially compare publishing a journal paper as to be equivalent to fighting a battle. Yeah, fighting a battle and winning the battle. Yeah, so yeah, because because of several reasons, as we'll see as we progress. Yeah, now, yeah, so given that it is clear that why one should really worry about publishing at good venues, yeah, because it sort of gives you the recognition among the peer group and helps you attract research grants. And we also understand the challenges that need to be tackled in order to publish at good venues. So let us now move to discussing how should you really, what are the key components of a journal paper? Yeah, I try to be as generic as possible. Yeah. So when you write a journal paper, there's something called as an abstract. This is the first part of the paper right after the title. Yeah. Now, what is abstract supposed to do? The abstract of the paper, of the manuscript, should give a short summary of the work that you have done in the manuscript. It should summarize the work done. Now, when I say it should summarize the work done, you can essentially basically break your abstract into several different parts. Maybe the first part of the abstract should set the context and give the background of the study. Yeah, it should essentially highlight the problem that you tackle and how is it related to the state of the art. Then it is important to address the rationale behind the research that you have done. Like, okay, let us say you have solved a problem, then you should as well highlight why solving this problem is relevant. Why is it important to address this problem? Let us say if you solve this problem, then what are the potential implications? The third part of the abstract must highlight the new methods that you develop, the new methodology developed, the new design that you come up with, or the new fabricated chip in which the measurements meet the simulation results. Yeah, so that should essentially form the third part of your abstract. You should emphasize on what really is new in your manuscript. Yeah, whether we talk about algorithms or whether we talk about deriving a new mathematical result or coming up with a new fabricated chip, in which the measurement meets the simulation results and at the same time does better than existing chips in terms of different parameters. Yeah, the last part of the abstract should give an idea about the main insights or the intuition or the main inferences that one can derive based on this study, and how the conclusions make sense. Yeah, what essentially is the impact of the conclusions that you make on in your research community. Yeah, so how will your results impact or influence other researchers in your field? Yeah, what essentially is the impact of your results that you obtain? What is the significance of the results that you obtain? Yeah, now writing an abstract is difficult. Yeah, for beginners it is difficult. Even for experienced researchers, when they work on different problems, writing a new abstract is an entirely different piece of cake. Yeah, so you have to it is not straightforward to write an abstract, primarily because all these four components have to be highlighted within 150 to 250 words. There is a word limitation when you write abstract. I guess this is the typical ballpark number for most journals. Abstract has to be short, concise, and it has to be standalone. Yeah. So if somebody tears your abstract, even then it should give a short summary of the work done in the manuscript, the new results developed, the new inferences obtained, and how that is going to influence the researchers in the field. Yeah, so that's the most difficult part. Yeah, it has to be written concisely within a word limit, and at the same time, it should highlight the points mentioned in bullets here. Yeah. Although we see that abstract is the first part of the paper, but it may be a good idea to start writing the manuscript. Start writing the abstract after your manuscript has taken a shape and it is sort of nearing completion. Yeah. So even with most experienced researchers, they generally take 3 to 4 iterations to refine the abstract to make sure that all these parts are properly highlighted and appropriately covered. Yeah. A good rule of thumb can be like a good rule of thumb in order to figure out whether you have written a good enough abstract is to essentially look at these 4 words. Yeah. After you have written your abstract, you can essentially judge whether the abstract has covered all aspects. Yeah, you should essentially see whether your abstract covers what you have done, what problems you have addressed. Yeah, and what is the relation of the problem to state of the art. Why did you address the problem that you addressed? Yeah, I mean, what was the motivation? What is the practical relevance? How did you do it? Yeah, so what, why, how did you address the problem? Whether you came up with a new algorithm that is near optimal and at the same time simplifies computational complexity, or whether you came up with a chip that sort of consumes less power, less space, and is better and is comparable to the existing chips in terms of different parameters. The last part is equally important. Okay, I mean, you've addressed what you have done. Why did you do what you did? And how did you solve the problem? The last part is so what? Yeah, why should researchers in your field really bother about the results that you have obtained? Yeah, what are them? Yeah, so essentially you should be able to convey the impact of the results that you have obtained. Yeah, so you should be able to quantify your main inferences. Yeah, how, I mean, whether you have come up with an algorithm which is like 10x less time consuming than existing algorithms, gives you 13.6x larger gains than existing algorithms. Yeah, so these are the 4 parameters that one should really check after you have written your abstract. So what, why, how, and so what. Yeah, whether these 4 things are covered, only then you understand that your abstract sort of covers everything in 150 to 250 words. Yeah, and generally it may be a good idea to write the abstract after your manuscript is has almost taken shape and is nearing completion. Yeah. uh, then the second part of your paper generally is keywords. Now it is important to put thought to as to what you should really include as a keyword, because most of the times when a paper is assigned to an editor for review, the way he chooses reviewers for your papers is through these keywords. Yeah, so you should very carefully, and at the same time you should make sure that the keywords cover your most important contributions. Yeah, because I mean, that will ensure that your manuscript goes to the right set of reviewers with the right expertise, and you essentially get reviewers who sort of have a know-how of what you have worked on. Yeah. Because if it goes to a researcher like who is like completely alien to what you are doing, then it may be difficult for him as well to evaluate your manuscript. Yeah. It is also used for indexing your manuscript, because let us say once your manuscript gets published, then yeah, in searches over different journals, maybe Springer, IEEE, Explore, it is through keywords only that your manuscript would appear in the search. Yeah. Yeah, so these are the first 2 parts of the paper. Then comes the introduction. Yeah, so while abstract has to be short and concise, should sort of cover all these 4 aspects, the what, why, how, and the so what aspects. Introduction is relatively, I mean, introduction gives you sort of, here you can sort of expand the context, yeah, the background of the study, its relation to prior art. Yeah. One part of the introduction can as well focus on the motivation behind the work, and the motivation has to be strong. I mean, does it impact society? What is the impact that your study is going to have on the community? Yeah, you should be able to convey the practical relevance of the problem that you tackle. Yeah, whether you are addressing a fundamental problem where several new challenges need to be tackled, or is it application specific? Yeah, so these things have to be brought out well in the introduction. Yeah, because uh, it is very important that the introduction is well written. Yeah, now a good way to judge whether your introduction is well written or the motivation behind your study is clear is you should be able to explain what you have done to a layman, and he should be able to comprehend and appreciate the work done. Yeah, if that's happening, I mean, so I mean a layman, I mean somebody from a non-technical background should also be able to appreciate what you have done, the kind of problem that you are trying to address, the impact it will have on the community, and the solution that you propose is a worthy solution. Yeah, so you should be able to explain it to a layman. Then so while the motivation is important, it is equally important to discuss thoroughly the related literature in the field, like yeah, in your field of study, like whatever problem you are trying to address, you should see whether there have been attempts in the past to solve that problem, and the related literature should clearly highlight how your work is different from what is already existing in the I mean, what already exists. Yeah, so this is because this is again very important, because unless you very clearly highlight how your work is different from the state of the art, what are the new aspects in your manuscript, nobody is going to buy your argument. Yeah, so you must ensure that you argue very strongly how your work is different from prior art. Some authors as well give a table of related literature where they clearly highlight. I mean, table of literature is a good way of summarizing how your work is different from what is already out there. Yeah, so it just gives a bird's eye view to the reviewers. And yeah, so once you are like once you have sort of convinced the reviewer that you are very different from prior art, your contributions are significant, yeah, your contributions are novel, you address challenges that are not trivial, yeah, non-trivial. The modeling that you perform is comprehensive. It sort of covers all aspects and sort of mimics practical reality. The analysis that you have performed is both thorough and detailed. You have meticulously planned your experiments. Yeah. The design inferences that you obtain, the new design insights that you obtain, they have a certain impact. Yeah, so they are significant. Yeah, it's not that the design inferences that you obtain, they make sense. They are intuitively clear and easy to comprehend. Yeah, so so this section is very, very important because if this is not well written, many a times the reviewers do not really go to the later sections. Yeah. Introduction, again, it may be a good idea if you have a lot of notations that you use in your manuscript. It may be a good idea to summarize it in a table of notations. It may be a good idea to create a table of acronyms depending on the space constraints that you have. And as well, I mean, add a paragraph related to how your paper and the later sections are organized. Yeah, so so there's again an equally important part of your manuscript. Then coming to the system model or the experimental setup. Yeah, so so the modeling has to be new. It has to be comprehensive. Yeah, what do I mean by comprehensive? One should make sure that when when you're trying to like develop your system model, it includes all non-idealities. Yeah, and mimics practical reality. Yeah, it is a common saying that all models are wrong. Yeah, and no model is correct. No model is perfect. But then there are models that closely mimic practical reality. Yeah, so they sort of capture all the non-idealities, all the imperfections that one is likely to encounter if you were to perform experiments. Yeah, so you should make sure that your experimental setup is robust enough. If you make certain assumptions in your study, you should make sure whether the assumptions that you make, they are justified. Yeah. Sometimes making assumptions, sometimes researchers make assumptions to sort of make the problem tractable. Yeah, make the problem doable. But one has to be careful enough to make sure that the assumptions that one makes is justifiable. Yeah, because making an assumption that's not justifiable may lead to wrong conclusions. Yeah, so one should make sure that when one is trying to develop the system model, the assumptions are justified well enough. Yeah, so most of the times it is a trade-off. So while one tries to develop the system model, most of the time it is like a trade-off between practical relevance and analytical tractability. Yeah, so yeah, how tractable or how doable the problem is, that does decide how you model the setup. But then you should as well make sure that you are not really making unjustified assumptions. Yeah, and the reviewers, when they review your paper, they do pay a lot of attention to the system model. If the model that you develop is not really capturing all the non-idealities, yeah, if there is a flaw in the model, yeah, so this is a section that essentially makes or breaks your paper. Yeah, if your model is good enough, new, comprehensive, covers all the details, yeah, mimics practical reality, is as close as possible to the practical reality, most of the times the paper goes through. Yeah, so the system model is extremely important. This makes or breaks your paper. Now, coming to methodology. Yeah, this essentially is the heart of your manuscript. Yeah, you won't really worry about writing a paper unless this is complete. Yeah, so nobody really bothers to even draft the introduction before this section is complete. Yeah, so so methodology is extremely important. Yeah, how thoroughly, how meticulously you planned your experiments, how rigorously the analysis, the mathematical analysis was done, how your analytical steps are novel, Yeah, what key challenges were tackled in the process of deriving a new result, or yeah, most of the times the detailed proof steps and derivations are given in the appendix because they sort of break the flow if they are included as a part of the main manuscript. But then, yeah, so it is equally important to highlight how the analysis that you have done is new and challenging. Yeah, so that because most of the times the reviewers, if they find the analysis to be trivial, yeah, the paper does get a negative feedback. Yeah. Now, it is not just about developing a methodology. One should as well try to highlight the intuition behind or the reason that motivated you to develop that methodology. Yeah. And let us say you derive a new result. How do you interpret that result? What are the new insights that you develop in the process of deriving that result, in the process of that analysis? Whether the insights that you develop, they make sense. Yeah. So it should not be like the you derive a new result because of the wrong assumptions that you make. You may start getting absurd conclusions. Yeah, so the conclusions that do not make sense at all. Yeah, so the methodology may, for example, include your algorithm description. If you have developed a new algorithm in order to meet an objective subject to certain constraints, then your algorithm can as well describe how you optimize. Yeah, how you essentially meet a certain objective subject to developed constraints, like how your optimized variables were obtained. At the same time, your algorithm description must highlight like the new aspects, the novel aspects compared to already existing algorithms. Yeah, the intuition behind the key idea should be well justified, should be highlighted properly. Now, when you develop an algorithm, yeah, there is computational complexity involved. Yeah, so it is equally important to highlight how computationally intensive the algorithm that you develop is. So basically, how does your algorithm compare in both performance and complexity in relation to the state-of-the-art algorithms? Yeah. So now this is equally true for any field that you take up. I mean, if you're worried about modeling, design, and fabrication, then you will worry about seeing that your modeling is unique, the design uses new aspects, and the fabricated chip, the measurement meets the simulations, and at the same time, it sort of gives you better performance than already existing ones. Uh, yeah, at low complexity. Yeah. You should be able to highlight the science behind the experiments that you perform in order to meet a certain objective. Yeah, so as I mentioned before, this forms the heart of your manuscript. Yeah, so this forms the heart of your manuscript, and nobody really bothers to write a paper unless this section of the manuscript is complete, up and running. Yeah. Then, so once you have developed a methodology, it is equally important to give some illustrations or examples in the form of, it can be in the form of numerical results or simulated results or experimental results, measurements, comparing your measured results against simulated results. Yeah, but when you do write this section, you have to be really careful about labeling your axis properly. Yeah, if the axis is not labeled properly, it again creates it sort of gives the feeling that the authors are casual. Yeah, so the axis has to be well labeled. The figures have to be comprehensible. They have to be good quality figures. Yeah, no noise in the figures. So essentially, it has to be good quality figures. The legends have to be appropriate, and it must aid the reader to capture what you're trying to convey. Yeah, so the legends have to be written in a way that it properly conveys what you're trying to convey. As a part of this section, you should also worry about explaining your experimental setup. If you are an experimentalist, you should worry about clearly stating the parameters that were chosen in order to run your simulations. And not just that, many times reviewers are interested in knowing the choice behind. I mean, the reviewers are interested in knowing the reason behind your choice for certain parameters. Like if you choose a certain carrier frequency, or if you choose a certain power level, what motivated that choice, whether it is really used in practical settings or is your choice not well thought of. Yeah, so it is equally important. So as a part of this section, the first part is generally to explain your setup very elaborately, justify the choice of the parameters, and then you put up these figures to illustrate the key ideas of the paper. Yeah, the methodology, the algorithm developed. So you can essentially, for example, you can look to plot the performance that your algorithm achieves against existing algorithms, and at the same time also comment on the complexity that it induces. Yeah, so this section is all about illustrations, giving examples, and putting well-labeled figures, good quality figures, and appropriate legends. Yeah, not just that. When you add a figure, there has to be a description, a very clear and concise description explaining the trends that you obtain in a certain result. Yeah, that should bring out the new inferences that you obtain, the insights that you develop. Yeah, essentially the key take-home message from those figures should be very comprehensible. Yeah, even so, generally, when a researcher starts reading out papers, we suggest that you should at least read the abstract of the paper. You need not really worry about much about the methodology, but then you should read the abstract, and then if you go to the numerical results, looking at the plots, the trends should make sense to you. Yeah, so you should essentially write your paper in such a way that even by just looking at your result without really worrying about the math or the algorithm developed or the chip that was fabricated, just by looking at the result, the results make sense to a reader who is sort of reading a paper for the first time. Yeah, may not have much of a background in research, but then still, I mean, the trend should be intuitively clear to him. Yeah, and if you sort of get a very surprising result, you should be able to very strongly argue why that makes sense. Yeah, I mean, you could have, for example, discovered something very new. Yeah. Then the last part of the paper is conclusions. Yeah, so conclusions is the structure of the conclusions has to be similar to an abstract, but then yeah, you cannot really keep your conclusions similar to the abstract. It has to be paraphrased and written in a way to highlight all that you covered in the abstract. Yeah, so the new aspects that were tackled in your paper should be highlighted. The new methodology that you developed, the new challenges that you tackled. Yeah, it should essentially summarize and quantify the new inferences that you make. Yeah, generally it is a well-established practice to write the abstract in present tense and conclusions in past tense. Yeah, but then yes, this is again subjective and may change from one author to the other. Yeah. Then then the last bullet is title. Yeah, so once you have sort of completed all of this, you really worry about the title that you should add for your paper. Yeah, and the title. So while deciding on a title for your manuscript, you should make sure that you have your title covers all the key ingredients. I mean, the key novel aspects of your paper are well covered in the title. Yeah, because yeah, that again is an equally important part. Yeah, so so what have we done so far? Let me summarize. We started out with discussing why should you really worry about publishing at good venues, and yeah, so we understand, like it sort of helps you go up in the academic ladder or the position that you are holding. It helps you attract research grants. Yeah, and it helps your work get recognized among the peer group. Yeah, but then there are challenges. We understand there are challenges associated with publishing at good venues. It is equivalent to fighting a battle, and the contributions of the paper have to be well motivated. Yeah, so they have to be well substantiated with, I mean, all the claims that you make in the paper have to be well substantiated. After that, what we did was we looked at the typical structure of a journal paper, right from the abstract to conclusions. Yeah, the paper can have as well one more part, which you call the appendix, and most of the times it is a good practice. So what do you include in the appendix? anything that breaks the flow of the paper is generally put in the appendix. Yeah. So for example, the proof of a result or something, a side result is generally put in the appendix. Yeah. And the key idea is that even if you take your appendix off, it should not really affect the content of your paper. I mean, it should not really affect the key idea that you wish to convey in the paper. Yeah. Yeah, so now given that we understand what the typical structure of a journal paper is, let us move to discussing what we must not really do. Yeah, what should be avoided? First thing is one should not be really casual when you're writing a manuscript. Yeah, yeah. So proofreading is a very important part of manuscript writing, and before submission, you should make sure that you have very meticulously checked your manuscript for grammatical errors. It is always a good idea to write simple sentences that convey the meaning concisely and precisely. Yeah, yeah. It does not help if you really write complex sentences that stretch for, let us say, 4 to 5 lines. Yeah, so it is always a good idea to write simple sentences, write them in a coherent way. Yeah, the flow should be logical. Yeah, the flow should be logical because only if your flow is logical and the lines are written in a coherent way, the reader will be able to appreciate what you're trying to convey. Yeah. So grammatical errors is a strict no-no. Yeah, you should make sure that there are no spelling errors at all. Yeah, because why are we pointing out to these? No matter how strong your system model is, no matter how deep the methodology that you have developed is, if your manuscript has grammatical errors, spelling errors, the flow is illogical, the presentation is incoherent, it will not go through. Yeah, so paper writing, these are all integral parts of writing your manuscript properly. Yeah, so you should double check your manuscript for grammatical errors, whether the flow that you have in the paper makes sense. Yeah, somebody who is not really associated with this work is able to comprehend what you have written. Yeah, as much as possible. Yeah, the references must not be incorrect. Yeah, also the cross-referencing must not be improper. So let us say if you are in your related literature, if you're trying to say that this work was done in manuscript A, it should not really point to manuscript B. Yeah, so such cross-referencing errors must be avoided. So when I say incorrect references, I mean the names of the authors must not be incorrect. Yeah, the spellings of the authors must not be incorrect. The title of the paper should not be incorrect. Yeah, the references must be complete. They should mention the volume number, the issue number, the page number, the month, and the year in which it was published. The very reason being, it could go to one of your references. Yeah, so the paper, I mean, your reviewer could be one among the authors in your references. Yeah, and if he so again, if it goes to a reviewer who is there listed in your references, and if he sees that the reference is incorrectly cited, again, that can draw criticism. Yeah, you should avoid, I mean, you should avoid writing the same content both in the abstract and the conclusions. Yeah, so these are all recipes for immediate reject. Yeah, abstract cannot be the same as conclusions, although they try to convey similar. So the idea that you try to convey both in your abstract and conclusions are almost similar, but then you should take care to paraphrase them in as much as possible. Yeah, and they should essentially highlight the what, why, how, and so what aspects of the manuscript. Yeah, the acronyms, you should make sure that all the acronyms that you use in a manuscript are defined the first time they are used. Yeah, and then on you can as well use the acronyms itself. Yeah. Sorry, so sir, how much time do I have more?
10 more minutes. Sir.
10 more minutes. Okay. Yeah. So the abstract cannot be the same as conclusions. The acronyms, the first time they're used, they must be defined properly. One should also make sure that there are not too many self-citations, or one should avoid formatting errors, overflows, and such things. Yeah. So essentially, it is so careful proofreading is an important part of any manuscript submission, and any submission without careful proofreading, yeah, invites immediate reject. Yeah, so one should make sure that proofread your manuscript before submission. Yeah. Now, how do you really find the appropriate venue or good venues to submit your manuscript? So before any submission, one should really read the aim and scope section of the journal that you're trying to target. Yeah, you should make sure that the theme and the objective of the journal matches the work that you have done. Yeah, your advisor can help here. You should definitely seek your advisor's suggestion in deciding on which venue you should submit to. Yeah, it may also be a good idea to see where the highly cited authors or renowned people in your field submit. Yeah, because that may give you a good idea about which of the venues are sort of appropriate and good enough so that you get strong feedback, and at the same time the feedback that helps you improve your work. Yeah, so finding the appropriate venue to submit your manuscript is equally important. Let me run you through the peer review process as well. So the review cycle, it generally varies from one journal to another, and the time to get first review decision, the time to revise, all these vary from one field of research to the other field of research. Yeah, they're very different from one journal to another. And however, the decisions, no matter which journal you submit to, typically they are one among these five. Yeah, you either get a reject, or you get a reject with resubmission allowed. Yeah, so this can be treated as a super major revision. Yeah, most papers typically get what you call as major revisions. So most good papers, their first decision that they get is a major revision, where you may expect to have 3 to 4 reviewers, and they may have detailed comments on your work. Both the positive aspects of the work may be highlighted, and as well the flaws or some of the points that you may have missed while preparing your manuscript, they may be highlighted. Yeah, very rarely papers directly get a minor revision or an accept. Yeah, so generally any manuscript that you submit has to undergo a couple of rounds of revision that may take time depending on the journal you submit to and the field of research. Upon submission, generally the manuscript first it goes to the editorial staff or the editor-in-chief, who based on your abstract or the keywords that you have put, or maybe based on the references that you have, may decide to give it to an area editor, who may then choose to assign it to an associate editor. The associate editor, again, mostly he may refer to your abstract, keywords, or maybe your references to figure out the 3 to 4 reviewers that it must go to. Yeah, so that is why it is very important to make sure that you are putting the right references, you are adding the right keywords, and your abstract sort of covers all, sort of summarizes all the new aspects related to your paper. Because putting these 3 things correctly, abstract, keyword, and the references, is an important part of your task, and that will enable you to find the right reviewers. By right, I mean the reviewers who have the right expertise to evaluate your work. Yeah. Now, whenever, so as I mentioned, whenever you submit a manuscript, it generally goes to 3 to 4 reviewers who sort of give comments on your work, feedback on your work, so that the quality of the manuscript is improved. Yeah, this is a very important part. Yeah, so so generally, when you get comments or the feedback on your manuscript, you need to prepare a response or a sort of a rebuttal to the comments raised. The key part you should understand is that generally you are given very limited time to revise a manuscript and prepare a response to reviewers, a point-by-point response to reviewers. In most journals, major revision may give you a 30 days to 6 weeks deadline to revise and submit. Yeah, but what are the key things that one must take care of while revising the manuscript? One must never resubmit the manuscript. So in case you happen to get a reject on your manuscript, you should never resubmit the manuscript to another venue without properly addressing every comment of the reviewers. It is a strict no-no for multiple reasons. One reason is let us say you get a reject from venue A and you decide to submit it to venue B without really addressing the comments of reviewers from A, it does not help. It does not help because there is a likelihood that even when you submit it to venue B, it may go to the same set of reviewers. Yeah, there's a high likelihood that something like that could happen. Also, when you receive feedback on your work, you should actually see how your work was interpreted by a set of individuals. Yeah, so that sort of gives you a feeling. I mean, maybe you wanted to convey apple and they took it as banana. So you'll have to basically make sure that what you're trying to convey is interpreted in the same way by the reviewers. If that is not the case, then maybe you may have to rewrite the whole paper. Yeah, so you'll have to, it is very, very important to see the comments that were raised on your work, and you should make sure that every comment is well addressed. You may have to run new simulations, you may have to derive new results or perform new experiments, may have to change a little bit of methodology, but then I think it is a fruitful exercise to sort of address every comment of the reviewer convincingly. Yeah, if you have got a major revision, then you should definitely prepare a convincing response, or prepare a point-by-point response to every review comment. And generally, when you prepare a response to any review comment, it should have three parts. You start with thanking the reviewer for the suggestion or the constructive feedback, and then you sort of give the response, the detailed response to the question raised. And then towards the third part of the response is generally you should highlight, in order to address that particular comment of the reviewer, what was the change that you made in the manuscript. Yeah, so how did you revise? How did you incorporate that particular suggestion of the reviewer in the revised manuscript? All right, so generally there are three parts when you prepare a point-by-point response to every review comment. When you make changes in your manuscript, it may be a good idea to highlight the changes in the revised manuscript so that when it goes to, when the revised manuscript reaches the same set of reviewers again, they find it easy to understand the changes that were made in order to incorporate their comment. Yeah. Yeah, one should make sure that the cross-referencing between response and the manuscript. So it should not be like, in order to address this comment by the reviewer, we included new simulation results in figure 6, but then it is figure 7 in the manuscript. Yeah, so such incorrect cross-referencing is not going to help. Yeah. And typically when you submit the manuscript, the response has to be included with the revised manuscript. Yeah, so so what I'll do is so that is all I wanted to cover as a part of this discussion. I'll be very happy to take up questions if there are any. Maybe if I have missed something, I'll be happy, and I'll invite the participants to raise questions. Yeah. Thank you. So with that, I'll stop. Thank you.
Thank you so much, sir, for that very informative talk. Now we can take up some questions from the chat box. So the very first question is, so what do you mean by revise here?
What do we mean by revised journal? Sorry, yes. Is that the first question in the? Okay, 1 second.
You can ask them to rewrite the question. You can ask them to retype the question properly.
Achha, what do you mean by revise here? Okay, revise. Yeah, so generally when you submit your manuscript, whenever you submit your journal to an appropriate venue, yeah, it typically takes about 2 to 3 months for the reviews to be received. Yeah, by reviews, I mean it may have gone to experts in your field who sort of check every aspect of your work, right from system modeling to the methodology to the numerical results and the inferences that you obtain. And so based on the work that you have done, they may have some suggestions to make. I mean, it can be both criticism and constructive feedback. Yeah, so in order to address those comments, you end up revising your manuscript. Yeah, very rarely does a manuscript, I mean, no manuscript is perfect, right, in the first iteration. Yeah, so when you submit a manuscript, generally you revise it a couple of times at least to incorporate all the comments of the expert reviewers before it gets accepted. So that is what I mean by revise here.
It is from Panorama Pandey. What did you tell about tense of abstract and conclusion?
Yeah, so generally it is an acceptable practice to write the abstract in present tense. Yeah, because when somebody reads your paper, just by reading the abstract, he should get an idea about what to expect in later sections of the paper. Once the reader reads the conclusions, so conclusions are generally written in past tense. The very reason being, uh, somebody who reads your conclusion should sort of understand like what was done in the manuscript. All right, so that is, I mean, as simple as that. Yeah, so abstracts generally in present tense so that the reviewer has an idea about what to expect in the manuscript. Conclusions in past so that yeah.
So the next question is from Ajay Kumar. He asks, can we use symbols in title instead of micro and known abbreviations like ECG or DC in title?
See, yeah, yes. So as long as these abbreviations are well accepted in the community, yeah, for example, ECG is a well accepted acronym in the community. So I would suggest yes. Yeah, you should. You can as well use titles, but then there are certain journal venues that have restrictions on number of acronyms that you can have in the title. Yeah, so you cannot have really multiple acronyms in the title, but then yes, well accepted acronyms are allowed. Yeah, if they help you write shorter and precise titles.
So the next question is, what is the difference between a letter, conference, and journal?
Okay, so there are these are very different venues for submission. Generally, what happens is, let us say you solve a problem, yeah, and if you have solved that problem, so it also depends on the scope of the problem. In the sense, there could be problems that do not. Okay, let me start this way. So conferences are generally. So 6-page manuscripts, yeah, 6 to 8 pages of manuscripts. Again, that depends on the field of research that you are. So for example, for authors from computer science, a conference is much more valuable than a journal. But for somebody from a EEE background or an electrical background, a journal is generally considered more valuable than a conference, because journal is considered to be a much more thorough piece of work. Thorough in the sense it contains all the detailed analysis. Yeah, because for the very reason being, journals you get a lot more space. Yeah, the page constraint. I mean, you can as well write 10 to 12 pages long detailed papers and submit it to appropriate journal venues. But with conferences, you generally have a page constraint. So to conferences, you submit either a 4 to 6 to 8 pages of manuscript, and conferences are not as detailed as journals. Letters can be regarded as shorter journal versions. The very difference between letter and a journal is that, so letters are also considered as journal papers, but then letters have a faster review cycle compared to journals. Yeah, with conferences, you as well have to, as an author, if your paper gets accepted, you have to go to the venue and as well present the manuscript before an audience. Yeah.
Excellent. Thank you, sir. So the next question is from Ramesh Babu. He wants to know, I have some results. Now, how to start my manuscript, whether from abstract or introduction?
No, so it is always a good idea to start from system modeling. Yeah, so generally abstract, introduction, and conclusions are written towards the very end. Yeah, so if you have generated new results, the first thing that you should do is you should write down the system model. I mean the modeling aspect. Yeah, because while you write the modeling aspect, it may be clear that whether the assumptions that you made, they are justified. You are able to justify the assumptions made, whether your model is comprehensive enough. After you are done with the modeling, you should write the methodology, the numerical results section, the inferences or the experimental results you should write. Basically the middle section of the paper, which sort of constitutes the heart of your manuscript, should be written first, and then you spend time writing introduction, abstract, and conclusions. But yes, once you have the result, you should worry about writing the modeling, the methodology part in great detail, and make sure that uh, all the technical aspects related to the paper are clearly highlighted, and well articulated.
So, sir, he wants to know, how can we decide which journal to select for to submit our article?
So generally, in your field of research, you must be reading papers from renowned research groups. One way to understand where to submit is by looking at where those researchers submit their work for review. The other is if you're a research scholar, your PhD guide may be the first point of contact where he can sort of give you an advice on where to submit your work. I mean, which venue is the most appropriate for the work that you have done. But then, yeah, it is generally between your advisor and looking at the references, the papers that you read, where they submit, and so on. Yeah.
Thank you so much, sir.
You should as well make sure that the theme of the work that you do, it matches the aims and scope of the journal to which you plan to submit. Yeah, it should not be like your work aligns to a certain area of research and you end up submitting to something that where the aim and scope is completely orthogonal. Yeah.
Thank you so much, sir, for answering the questions. There are a few more questions in the chat box. So we would kindly request you to answer them. Because of time constraints, we would request you to answer them in the chat box itself.
Right. Sure.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
So once again, we would like to extend our gratitude to all the speakers and the participants for their valuable time and the insightful talk. With this, we would like to inform you that now is the time for lunch break and the next session will commence at 3 p.m. And this is for the information to the participants. There is a quiz on the third day of the workshop, and only who appear for the quiz will be considered for the offline workshop. Thank you so much.
Thank you.
Thank you, sir.
Thank you, sir.
वो बोल रहे हैं मैम को बोलने के लिए, जो मंडे को प्रेजेंटेशन देंगे। हॉस्टल जाके लॉक करके आ गया, यहीं से चला जाऊंगा। लोकल हॉटस्पॉट क्या है? जो चेन्नई समझ में आ रहा हटा ही दे। हाँ वही कर रहा हूँ। ये क्या है? नहीं फोटो चेंज करना पड़ेगा। फोटो नहीं हटाए तो कंटेंट नहीं हटा। फोटो में दिक्कत है। हाँ तो माइक्रो जेट लिखा है बस पता नहीं क्या है, पता नहीं हटा दे। एक्चुअली वो वही चीज क्या लिखा है? लोकल हॉटस्पॉट और माइक्रो जेट। ये बीच में कुछ तो है। वो जिस पेपर से लिया है वो नहीं दिख रहा है। उधर क्या लिखा है? हाँ यही कर ले।